Hi everyone, I am Ashok Kumar and I welcome you all to this PLC training program. First of all, thank you so much. Thank you everyone for a lot of patience because I initiated this training program from LinkedIn, and once I initiated, just after that I started getting too many responses from your sides, and I need to reply each and everyone, which was very difficult to manage. We all know that LinkedIn don't has such tool where we can reply each and everyone at the same time. So it was quite difficult for me to DM to reply to all the DMs which I was getting. But thank you for your patience because you waited a lot for this thing. And finally, we are on the day when we are having this PLC training session. Also, let me also clarify you one thing. We know that this training is completely free and the certification is paid. So you will get the link just after the sessions for that certification, which is already mentioned that it is 100 plus taxes according to Indian currency. But the main motive of collecting this amount is not to get benefited. Actually, we are donating, or let's say, we are raising the funds for social cause. That is why we have just put this amount for certification, right? And other than that, you also understand the 100 rupees is, or Indian currency 100 is not too much amount. So that is why we are not putting too much pressures. So it is completely your choice if you want to take it or not. That is why it was optional in the form, right? Now, further, let me also tell you one more thing here that I am recording this session, okay, and this session will be live on the day when we'll be having live session. That means obviously when you are watching this, so this will be a recording, but not to worry about the things because it does not mean that a live streaming has only recording, because I am recording this to manage each and every query at that time, right? So I am pre-recording this session so that when I live this session on 21st February, that means today, obviously. So uh, according to that, like what I actually want to handle all the queries. So I'll be there in that live session. Okay. So obviously, my recording would be playing there, but I would be sitting to answer each and every query, which you can comment me, which you can drop me on the chat box. I'll just pause the recording at the same time and we'll discuss about that query. And also, I'll try to have around half an hour session for each and everyone's query if you have, right? So now let's don't waste too much of the time. I guess you don't need my introduction because we are already connected on LinkedIn. Now, let me tell you on behalf of which company we are doing this. So we are doing this on behalf of Encino Research and Development Private Limited. So greetings from Encino, greetings from my side. And again, I welcome you all to this PLC training program. And obviously, I know that 2 days are not enough, but later, after the response, after the feedback of these 2 days sessions, obviously, I look for a long period as well. And that also I'll try to keep almost free, right? So let's continue and discuss about what we are going to have here, right? So as it was already mentioned that we will be doing PLC based on Allen Bradley and Siemens, right? So currently this one is the Allen Bradley PLC which I am showing you, and there on the top the Allen Bradley, and I have another model as well. I'll show you that one if we get the time, right? Other than that, the softwares which we need to work with is already shared with you. So whatever I'm doing here is not just theory. I'll be doing completely practical and hands-on. So I request each and everyone to try from your end also if you want to learn the PLC in hands-on mode, not just a theoretical, right? So let me share my screen to start with the main concepts which we have to deal here in these 2 days. Just give me a second. I'll share my screen here. Okay. So PLC, right? PLC mean programmable logic controller. A controller which can be programmed through logics. A controller which can be programmed through logic. That means it's a kind of hardware which we have to manage through logics. And logic is nothing, just a ladder logic programming. When we talk about PLC, obviously we know that we are using the PLC for the purpose of automation, right? And automation mean what? Automation mean like if we want to do the task automatically, if we want to reduce the human efforts, if we want to reduce the manpower, if you want to reduce, if you want to increase the efficiency, productivity, quality, time management. For those things, we do basically what? Automation. And PLC is one of the tool of that automation. There are two type of controls. The one is manual control and the second one is automatic control. So currently we are talking about automatic control, and that automatic control we are doing with PLC. We have other tools as well like embedded systems, DCS, and too many tools are there, right? But currently we are focusing on only PLC. But let me clarify where we use embedded system, where we use PLCs. The two categories I'm going to discuss here. For that, I need to categorize this automation into three different categories, right? I'll put around half an hour for theory, and just after that, we'll be discussing about the hands-on practical, because it is also important to understand the facts, what are used for PLCs, what are used for automation. So that's what we are doing for now. So I'm categorizing this automation into three different categories. The first one is soft wire automation, and second one is hard wired automation, and third one is factory or industrial automation, right? Factory or industrial automation. I'm writing it fastly. Maybe sometimes if I miss any spell or something like that, so please don't mind, try to understand, right? So let's start with the software automation. The automation which is a kind of flexible automation, mean like where we can move the machine from one place to other place. It's not a fixed wire type, it's not a wall mounted wire type. Whenever we need to shift the automation from one place to other place, we can do it easily if we have flexible or software automation. Let me give you a few examples for this. All the home appliances which have a smart systems, let me clarify how. Washing machine, refrigerator, induction, oven, all these things we have with automation, right? And all these things are simply what? Not the fixed type of wires. Simply we need to plug in and plug out to shift from one place to other place. Is simply a category of software automation. Second one is hardwired automation. The automation where obviously the hardware, the wiring part is fixed, hardwired, or we can also call it fixed wired, where the wiring part is completely fixed and we cannot move it from one place to other place. If we try to do that, we may face the losses in the wiring part, or maybe the structure, or maybe the device. Few examples: elevators, escalators, automatic door locking systems, mainly the office appliances. Those are the category of hardwired automation or fixed wired automation. Third one is factory automation or industrial automation. Industrial automation mainly will be using obviously in factories, industries, in the manufacturing units or the production units or the quality units, right? So that comes under industry automation, where we may need to control the robotic arms, the conveyors, maybe the motors, boilers, actuators, contractors, relays, and other type of loads or other type of electrical parts. So that comes under the category of factory automation, right? So in this way, I have divided this automation into three categories. Now, why I divided? Because I was about to tell you that there are two tools, mainly embedded systems and PLC. So where we use PLC, where we use embedded system, that we can understand through these three types, right? So when we talk about the home appliances, basically, here we use embedded systems, right? And when we use hardwired or office appliances, there also we use embedded system. And the third category, obviously the R category, where we use industry automation, factory automation, there we use PLCs. We have other tools as well with PLC. PLC standalone is not enough to control your complete setup. So we need other tools as well. We'll be discussing here, right? First, I'm telling you what is embedded system and what is the difference between embedded system and PLC. When we talk about embedded system is also the combo of hardware and software. PLC is also the combo of hardware and software. Hardware mean your machine, your device, your controller, and software mean programming, where we can program it, right? So embedded system and PLC both have same structure as a basic. They have combination of hardware and software to customize your requirements, to customize your control, or to customize your electric loads or outputs, right? But embedded system is a hardware where we use microcontrollers, and PLC is the hardware where we use the controllers, the size difference, right? Other than that, the microcontrollers have the operating voltage of around 5 volt of DC, whereas the controllers, PLC controls especially, have the operating voltage of around 24 volt of DC, right? So with the 5 volt of DC controller, if you want to control your three-phase motor or a single-phase motor, it would be quite difficult to control it. We need additional components and we need to manage the power as well. But when we talk about the PLCs, there we use 24 volt DC operating voltage, and standalone, obviously, we cannot do with PLC also. We need some additional information. We need some additional devices like drives and others to control the motors. But frequently we use PLCs because PLC is the tool where the programming part is easy, where we can directly interface it with the drive and drive directly interface with your motor. Let me have a block diagram to clarify this with easily. Okay, so I'll do what? I'll start with embedded system and then we'll be coming back to this one, right? So let's say at first, suppose we have a motor, okay, and the operating voltage is around 24 volt of, 12 volt of DC. We need a motor to operate 12 volt of DC motor, correct? Then I have a microcontroller, the category of embedded system, right? So obviously, microcontroller has the requirement of 5 volt of DC, and the supply which we are getting, I'm telling you this according to my Indian country, okay, that is 220 volt of AC. So obviously we need to convert this 220 volt of AC into 5 volt of DC so that we can provide that to your microcontroller. Now, microcontroller is the combination of hardware and software. So obviously microcontroller is going to do what? Microcontroller is going to control your motor on the basis of the program, on the basis of the customization which user can do, and we all are the users, right? So let's say we have a sensor. S mean sensor here, I'm writing in a short. So what you want, if your sensor give the logic 1 and if it give the logic 0. Now what are the logics? Logic 1 mean on and logic 0 mean off, right? So if your sensor is sensing anything and if your sensor is not sensing anything, so I'm currently talking about two logics, 1 0 and digital sensor, right? Accordingly, your controller is giving two logics. According to your program, you have mentioned in your program, if sensor is getting the logic 1, microcontroller has to give logic 1 to turn on the motor. And if your sensor is getting logic 0, microcontroller has to give logic 0 to motor to turn off. Getting my point, right? So now this 1 is obviously in the form of 5 volt and this 0 is obviously in the form of 0 volt. Now when we're talking about the operating voltage, if it is 5 volt of DC, so obviously the output of microcontroller is also 5 volt of DC. But on the other hand, where we have to operate the motor, it has the requirement of how much? 12 volt of DC. So do you feel that this 5 volt of DC is enough to control the motor? Obviously not, right? So what we do, we use a motor driver IC in between. So I'm writing it motor driver IC. So we use, let me name one or two IC, L293D and L298N. We use these IC with robotics as well, right? So what I have done, I have 220 volt of supply that is converted to 5 volt of DC to operate the microcontroller. Then we have a sensor to sense two different logics, 1 and 0, right? And according to these logics, microcontroller has to respond. So microcontroller is responding 1 and 0 with respect to 1 0 from sensor, where 1 is the logic, 0 is also the logic in binary form. But according to the current, according to the electricity, according to the power, it is 5 volts and 0 volts. So as I mentioned, that this 5 volt is not enough to operate your 12 volt of DC motor. That is why what we are doing, that is why we are going to have one motor driver IC in between. So what this IC will do, it will take 12 volt external supply of 12 volt, right? Now, how we'll get this external supply? So obviously here we have 220 volt of AC source. We will not directly convert this to 5 volt. First we will convert it to 12 volt and then we will convert it to 5 volt. 5 volt is required here. So we'll give this to this 5 volt and 12 volt is required here. So we'll give 12 volt to this motor driver IC, right? Now what this motor driver IC is going to do, motor driver IC is going to control your motor on the basis of what logics it is getting from microcontroller. Let me repeat what I said. Slowly, I'll say again. Motor driver IC will control your motor on the basis of what logic it is getting from microcontroller. It is not like if we have connected this 12 volt of DC, it will directly pass to motor. No. If we do this, obviously there is no role of microcontroller, there is no role of sensor, and even there is no role of programming. So we have to establish each and everything in a loop. So what we did, sensor will give the logic 1, motor microcontroller will give the logic 1 to motor driver IC, and then my motor driver IC will give the logic 1 to motor. But this time this logic is 12 volt. Why? Because it has 12 volt of because it has 12 volt of external supply. So that is the reason why we are going to have it, right? Now let us assume if we change the scenario. Let us change the scenario now, right? So let's come here again. Just give me a moment. Yeah. Just give me a moment. Yeah. Let's come to the point. Now, what I'm doing, I'm going to change each and every scenario. And in this scenario, obviously, now I'm going to use something else. And what is that something else? So now we are going to we have to replace the 12 volt of DC motor with three-phase motor. Okay. Now we have to replace this 12 volt of DC motor with the three-phase motor, right? And if we do it three-phase motor, obviously where we using this motor driver IC, where we were giving around 12 volt of DC external voltage, which now we cannot give. So at that time we need to give what? Now we need to give around three phase of external supply. Why? Because looking for the motor was looking for how much? The motor was looking for around three phase of supply. If your motor is single phase, then you need external supply of single phase. If your motor is high voltage DC motor, you need external supply of high voltage DC motor, right? So let me tell you again. We have a motor which require three phase of input. Earlier it was 12 volt of DC, but now we need it three phase. Correct? Next, your IC, motor driver IC, it was getting external voltage of around 12 volt because that time the motor was 12 volt. But now we have changed the motor to three phase. So we need the external supply of three phase as well. But this motor driver IC, as we mentioned, L293D or L29810 or any IC, IC mean integrated circuit. It does not has the operating voltage more than 12 volt or maybe 18 volts sometimes, right? Because with the power electronic components, we can work with up to 18 volts of DC as well. So now we need to replace this motor driver IC. Now, when we replace this motor driver IC, obviously we need to include another component. So let's say now we are including electric drives, and we have too many categories of electric drives. Generally, what people start saying about drives, VFD. So we don't have only one option, that is VFD. VFD is variable frequency drive. Other than that, we have VVD, VID. VVD is variable voltage drive. VID is variable current drive. Then we have AC drives, we have DC drives, we have universal drives, we have synchronous drive. So drives are basically available as per your requirement. If you use high voltage DC motor, you can use a drive which can control that DC motor. If you have a motor of three phase, you can choose your device according to that requirement. Correct? So generally we say it electric drive. So now we need to replace that L293D IC or L29810 with what? With this electric drive. So now this electric drive will get three-phase input externally and will give it to motor, but according to the logics which it will get from controller. Now I have replaced the microcontroller as well. Why? Because microcontroller was giving around 5 volt of DC, whereas all the electric drive needs the input around 24 volt of DC. So that is why we need to replace the microcontroller with PLC. So that's how the scenario comes. Why we have fixed this, that we will use embedded system in home appliances and office appliances, because there we have the operating voltage around 5 volt of DC, and with the ICs we can control the DC motors, right? When we have AC motors, there also we may need relays and other required components. When we include the role of three-phase motors, then obviously we need to replace the ICs with the electric drives, and we need to replace the microcontroller with PLC, because drive need the input of 24 volt of DC, and that microcontroller is not enough to provide 24 volt of DC because it is giving 5 volt of DC output. Correct? So in short, what conclusion we have? We have a conclusion, very simple and clear, that we will be using this PLC in industrial scenarios. But out of this, we have like one more point to be discussed here. Your microcontroller was giving 5 volt of DC output, and your drive, electric drive, which we just said, electric drive need how much? 24 volt DC input. So is it possible if we convert that 5 volt of DC output of microcontroller to 24? Yes, obviously, we can do that. We just need to boost up the voltage. I'll repeat what I said. Your microcontroller is giving 5 volt DC output. Your electric drive need how much? 24 volt of DC. So what we can do, we can boost this 5 volt of DC up to into 24 volt, which we can provide to drive to control your motor. It is also possible, right? But like, what is PLC actually? PLC is actually the combination of microcontrollers itself. When we talk about a PLC itself has too many microcontrollers inbuilt in the circuitry of your PLC, right? So basically what we can do, if we have to do a 5 volt of DC to 24 volt of DC, we'll use microcontroller giving 5 volt. Now we need to boost it to 24 volt. So in between, we may use voltage boosters or choppers, DC choppers. It will boost your 5 volt of DC up to 24 volt to provide to your drive, and then everything would be managed clearly. But if I tell you the other part, microcontroller plus choppers and all these things are going to make a PLC itself. right? So in short, again, now we have a new conclusion. We use embedded system in the categories of software automation and hardware automation, where we have operating voltage up to around 12 volt of DC. And we may use PLCs where we have the operating voltage greater than 24 volt of DC, right? Now, embedded system is also used in industry, but in the form of PLC. And PLC we do not use where we use embedded system like a washing machine or refrigerator, because PLC is quite costly. If we start including PLC in your, let's say in a washing machine, it will cost you around 3 times of the present cost of your washing machine, right? So that is the reason why we don't use PLC in those applications. So now I guess we are clear about what is automation, what is PLC, where we use a PLC, where we use embedded system. So further, we are not going to discuss about these things. Now we'll be discussing about only PLCs, right? So let's go forward. PLC may have different categories, may have different vendors, different categories. Like some PLC may have your only digital input outputs, right? Some PLC may have analog input outputs, and some PLC also may have digital plus analog input output, right? And other than that, some PLC also have the relays inbuilt, okay, and some PLC don't have the relays inbuilt. So that completely depends upon the design. So this is according to the signals which I have mentioned. We know digital is simply 0 and 1 logic, yes or no, true or false, high, low, okay. And when we talk about the analog mean the continuous values. Okay, let me give you example to understand this very clearly. Let it say if you have to turn on the motor and turn off the motor, simply you have to give two logics, either 1 to turn on and 0 to turn off, right? But when we say we have to control the speed of motor, so obviously we cannot simply say 1 0, because we don't have to only turn on or turn off the motor. We have to obviously control it. So to control your motor, we need different voltages. And when we talk about the digital, 0 mean 0 volt and 1 mean 24 volt, the fixed voltage. But in the case of analog, we need to provide the variable voltage starting from 0 volt to 24 volt, so that if we boost the voltage, if we increase the voltage, the speed may increase. If we decrease the voltage, speed may decrease. So when we're talking about variable frequency drive or variable voltage drive or variable current drive, so there are three factors: frequency, voltage, and current, which we use to control the speed of the motor. And all these three are directly proportional to your speed. If you increase frequency, voltage, current, obviously speed increases. If you decrease frequency, voltage, and current, obviously speed decreases, right? So that these all three are the important factors in the case of VFD, VVD, and VIDs, right? Now, analog is simply what? Where we give the range of your voltage, where we may give different voltage. That is why we have mentioned the continuous, right? Continuous signals. And this was according to the outputs. Now, if we discuss according to inputs, how output? Because we were talking about motor where we need to give the current. So which mean your controller is going to act as a output in that case, is going to act as a source in that case. Now, just opposite to that, let us discuss digital and analog according to input signals as well. Input signals. So let's pick another example to understand this. Let's say we have a sensor which is going to sense that is there an object or not. Let's say this is a sensor and it has to sense that in front of this the object is there or not, right? So if I don't put an object, obviously it will give the logic 0 because there is no object. And if I put an object, obviously it is going to understand that the object is there, so give the logic 1. It is digital, simply saying you yes or no, true or false, high or low, 1 or 0, right? Now, another example to understand the analog. Now, let's say if we have to read the temperature or pressure, or volume or moisture or humidity. I mean, all the physical parameters which we have around us. So whenever we need to read those values, these things are not fixed. We know all these physical quantities we cannot see from our eyes, but we can feel it. And these quantities are continuous quantities because these quantities are changing every moment, right? Have you ever heard the temperature is fixed 20 degrees Celsius throughout the day? Never. Have you ever heard that the humidity is fixed throughout the day? Never, because these are these are changing continuous quantities changing with respect to time. At every moment, it is changing. We don't have to sense whether there is a temperature or not, right? It has to sense whether there is an object or not. That's a different scenario. But we don't have to sense there is a temperature or not. Temperature is always right. Currently, you are sitting in any other country, I am sitting in any other country. So that does not mean that at your place temperature is not there, at your place humidity is not there, moisture is not there, at my place it's not there. Everything is surrounding us and it is changing with respect to time. And those quantities with changes with respect to time is called analog quantities, right? And continuous quantities. And to read those, we need what? Analog inputs. I guess now you clearly understood about the logic of digital and analog, right? Now I am going to categorize the PLCs according to their vendors, okay? Different vendors we have, and we already know that we are going to cover with Ellen Bedley and Siemens, but let me also name few more which are the vendors or the brand names of PLCs, right? So we have a Delta, and then we have Panasonic, we have LG, we have Toshiba, and we have Astra from India, okay, and then we have Mitsubishi. So a lot of PLC options we have with us, right? Ellen Bedley belongs to USA, Siemens belongs to Germany, Delta China, rest you can search, okay, because that doesn't matter which PLC belong to which country. But yeah, of course, when we talk about the industry scenario, the most of the time you will be like looking at around four PLCs, mainly Ellen Bedley, Siemens, Mitsubishi, and ABB. These four are very, very important, and these four are like a huge demand in the market. Industries are mostly dependent on these PLCs. And out of this, if personally I have to recommend something, so I'll recommend Siemens, right? The German brand, right? But when we start learning the PLC, that time I recommend always to start with Ellen Bedley because Ellen Bedley has too many options and it is easy to understand. So currently I'm doing the same. I'll start training you with Ellen Bedley. Okay. Ellen Bedley, which has two different models. The one is micrologics and the second one is control logics, telling you about the basics, right? And micrologics has a different series available. Macrologics and control logics are what? Model names. And then in micrologics, we have different series available like 1000, 1100, 1200, 1400, and 1500. Then under these 1000, 1100, 1200, 1400, 1500, we have again different varieties according to digital, analog, and number of inputs and outputs. So let's don't discuss each and everything because we have too many varieties of PLCs. So currently I'm talking about this one, right? So this one is Ellen Bedley Micrologics 1000 series PLC. This one is SMPS. SMPS we use to convert 220 volt of AC input to 24 volt of DC input. Why we need this 24 volt DC? As I mentioned, this PLC has the operating voltage of 24 volt of DC, right? Sometimes it is not also required because some PLCs, especially Mitsubishi and Siemens, have SMPS already inbuilt inside the PLC. So you don't have to give the 24 volt DC as an auxiliary supply to turn this on. In that case, you may directly give 220 volt of supply to your PLC. But this model don't have that such option. That is why I have connected SMPS, right? After this, it has around 6 inputs. It is a training kit, okay? So for that, I have connected few buttons, and for outputs, I have connected few LEDs. So here we have 1, 2, 3, 4, 5, 6 inputs and 1, 2, 3, 4 outputs for now. Okay. So this means let me write the complete name of the PLC which we are going to have for this training program. This one is Allen Bedley Micrologics 1000 24-volt DC input and 10 IUS, right? AB mean Ellen Bedley, ML mean Micrologics, 1000 is series, 24-volt DC input is the auxiliary supply, and 10, let me mention one more thing, DIUs, digital input outputs. And out of these 10, we have 6 inputs and 4 outputs, right? What is the flow diagram or the block diagram of PLC? At first, we have input, then we have PLC, and then we have output, right? Now, what is input? Input is obviously part of instrumentation. And then what is, I already mentioned that if any spell mistake, please don't mind. Output is the part of electrical. Okay. Now, what comes under this instrumentation? So there may be too many things like push button, emergency buttons, push buttons, toggle buttons, too many categories of buttons, right? Then maybe sensors or any other sensing elements, or maybe a transducer, right? And on the output side, electrical especially. So there we may have a motor, there we may have a relay or coil or load or valve or conveyor or pump or any other load, right? So these things may be at the output side or electrical side of your PLC, right? So what PLC basically does, it take the inputs from instrumentation and react according to your program, which you have already uh, uploaded to your PLC, and then after that give you the output. Okay, it reacts according to your program. Whatever input it is getting from instrumentation, it senses that input. After sensing the input, it analyzes your program and check what user demands, and according to the demand of user, it has to react or it has to respond to the output, right? Let's say if you turn on the push button, motor on, it will do. If you say turn when the button is off, motor off, it will do. If you say if a sensor is giving you one logic, you have to turn on the conveyor, it will do. If you say a sensor is getting zero logic and according to it PLC has to turn off the pump or conveyor, it will do that. Okay, so whatever you want, whatever is a requirement, you simply need to write that in your programming. Okay, programming is not like a C language or Java language or any other computer language. It's simply a ladder logic diagram. So we'll be discussing it further after this. Once we are clear with this input, PLC and output, obviously when PLC has to check your program, PLC must be having memory and it must be having a brain called CPU, right? So all these things are already inbuilt in PLC, right? And other than that, PLC internally have few more things to sense your button inputs or sensor inputs. It may have optocouplers, or it may have the transistors phenomena, photo transistors especially, so that it can sense the inputs, and according to that it react the output to either relay based output or non-relay based output. There may be anything on the output side, but obviously it has 24-volt DC input and 24-volt DC outputs only. So whenever you plan to control three-phase motor or anything else, obviously you need a supporting unit called electric drive, which we have discussed earlier, right? Other than that, PLC is completely for the automatic control, right? But however, if you want to get each and every record, if you want, suppose a PLC is doing automation in your plant and for 3 or 4 days you are not there. Once you come back, you want to monitor each and everything what has happened earlier. So for that, we have SCADA options available. SCADA is nothing but a supervisory control and data acquisition system. Let me mention here, it is a supervisory control and data acquisition system. Okay, so that is your SCADA. SCADA is completely software part, which we need to install in your PCs, connect with PLC, connected with plant. So whatever your plant is giving the logics, the signals to PLC, or let's say whatever your field devices mean sensors, transducers, or the feedbacks from your outputs. However, you're getting those signals giving to PLC and then PLC giving to SCADA, so that whenever you come back after 3-4 days, it may have each and every record with the help of graphs or theoretical form. Everything would be available with your SCADA. So basically, I can say SCADA we use for monitoring and controlling. Monitoring task you already understood, whatever field device giving the logics that we need to record in the SCADA system so that you can monitor it later once you come back. What is controlling? Controlling, suppose if you want to shut down the plant, or if you want to control the speed of your motor, or if you want to increase the production line, if you want to slow down the production, if you like whatever control you want, which you can directly apply through PLC, you can also do those using SCADA. How or why? I mean, like SCADA is going to give the logics to PLC, and then PLC is going to give the logics to your field devices. That's how the control. So when we talk about monitoring, it is field to PLC to SCADA. When we talk about controlling, it is SCADA to PLC to field, right? More advanced, if you want to go, then we have HMI, which is called human machine interface. It's kind of a touch machine, right? And it is in my language, I'll say it is advanced version of SCADA. SCADA is completely software which we need to install in the PC, but HMI is what? HMI is the combination of hardware and software. It is advanced version of SCADA where you already have a hardware, a touch screen where you install that SCADA, right? Or not to install, you just make the SCADA system and upload your SCADA program to HMI, and then using that touch panel, you can give the signals to PLC to field device, and you can get the signals from field device to PLC to HMI, right? Using communication cables and all, right? So that is called HMI. So in case of HMI, you not need such PCs or desktop or workstations to operate. But yes, initially, when you set up the things, when you prepare the programs and all, obviously you need your PC, desktop systems, laptops, or workstations, right? I used one more word here. Let me clarify that as well. Then we'll move further for the programming part. That was communication. It is also important to communicate with your PLC, right? Like this one is PLC. So if I have to upload or if I have to download a program to this PLC, obviously I need a cable, right? Or such modem where I can communicate. So I'll divide this communication in mainly two parts. The one is serial communication and the second one is parallel communication. Serial communication is one to one, right? And parallel communication is one to many, one to one, and the parallel communication is one to many. One to one mean like you have a PLC and a PC, so they both are communicating with each other. It's one to one communication. Then one to many is what? When you have a PLC which you want to control using multiple PCs. Single PLC with controlling with multiple PLCs is parallel communication, one to many. So there are few standards for serial communication. The standard is RS-232, and for parallel communication, there are two standards, RS-485. There are two standards, RS-232 and RS-485. RS-485 has the connectors, which is RJ45, right? RJ45. And when we talk about RS-232, it has too many connectors like DB9, and it may have PM02, and it may have PAT32. So that completely depends upon the PLC port options, right? So currently, if I tell you about my Allen Bradley PLC, which we have currently here, right? So this one is basically serial communication based, and the complete name of the cable is PM02, starting from PLC, and so we need to connect PM02 connector to the PLC and Then further, I'm using one DB9, and that is your male and female. And then further, I'm converting it to USB. So currently, this one is the cable which I'm using to communicate with my PC, right? Next is simply we have to discuss about the programming, and before programming we also need softwares which already I have shared with you, but let me name them. RSLogix is the software which we use for Ellen Bedley programming, and RSLinks is the software which we use for Ellen Bedley communication. So Ellen Bedley has two different softwares, right? One for programming and other one for communication. But when you go for Delta and Siemens, there you have a single software for programming as well as communication, right? Programming mean where you create program, where you develop and run your program, where you download and upload your program. Communication mean what? Connecting cable is not enough. If you suppose you want to download or upload the program to your PLC from your PC, so connecting cable is not enough. You need to first communicate. So I'll tell you each and every step when we'll be doing this, right? After this. Now, next is data. No, one sec. Also need to mention one thing. These softwares are not open source. Okay, not open source mean you cannot use it for free of cost. These are licensed version softwares. So you need to purchase the license, or either you need to purchase the license or you can download the trial versions from the official website of Rockwell Automation. Rockwell Automation is basically part of Ellen Bedley only because they are the distributors of Ellen Bedley. Okay. So they prepare the software so you can download the official versions or the trial versions, whatever you need from your side, right? Whenever we work with RSLogix and RSLinks, we need the hardware as well to communicate, or otherwise we need emulator. Okay. If you don't have hardware, so you can work with the emulator, because currently I understand that everyone is not having their own individual hardwares to learn with. So obviously that time you may install the emulators, which I have shared already in the package with the installation videos. Or otherwise, the second option which you can do is uh, simulator. Okay, so now I'm talking about simulator I'm going to use here is LogicPro. I'll show you in both RSLogix and RSLinks, and then LogicPro as well. Okay, so that you can do work in industry as well, and when you have to practice at your home, you can do it with LogicPro as well. So whenever we start and we don't have hardware, I recommend to start with LogicPro and then jump to RSLogix. That's what I will be doing here also. But to make it like interesting, because if I'll do everything in simulator, you'll get bored and then you will say nothing was related to PLC. So in starting, after creating a very first program in the simulator, I'll be doing that program in your main software, that is programming RSLogix software. Okay, so I have shared this simulator software also with you. You can download and install. The steps are already given in the videos. Okay, after this we are doing ladder logic programming. We are doing ladder logic programming. Ladder mean stairs, mean steps. So we'll be doing the programming step by step, stairs by stairs. Okay. And for that, we need two inputs. We need two sides, left side and right side. Left side is the input side and right side is the output side. Okay. Without wasting the time, I'll switch to the software part to clarify you what are the things we have to use here. Okay, and what are the inputs, how we use it, what are the outputs, how we use it. In this PLC, do remember we have 6 inputs and 4 outputs. You have to purchase the PLC according to your requirement, according to your industry requirement. Okay, I'm continuously speaking from last around 40 to 45 minutes. I'm not sure about the time, just saying. So I need a break of around 5 minutes only. Okay, I'll be come back. But as we know that this is a pre-recorded session, and for now we'll have a query session. So whatever queries you have, let's discuss those things right now, and then we'll be moving further. Okay, and meantime, like those don't have any query, they can recall each and everything what I have discussed here till now. Let's wait for 5 minutes and then I'll continue. Okay, in this meantime, I'll stop sharing my screen.
Guys, as I said, I'm live. So if you have any questions, please write your queries quickly to chat so that we can continue it. I can give you all the solutions for that. So I guess there are no such technical doubts. So let me use the chat again to answer each and every query. Although I'm replying to chat box continuously, but still, let's try to complete all the questions again. Today's session is still at what time? So the timings almost for next 2 hours we'll be live, right? Almost for next 2 hours we'll be live, as discussed and message through the Telegram and WhatsApp. Sir, after session compilation, these 2-day video is remaining present on YouTube in future. So I'm not sure about this. I have said this many times because that depends upon the company's decision. So I don't think I would be the right person to answer this right now. So let's wait. And as per too many questions about the same thing, I have got one thing in my mind that I'll discuss with the company's management. Whatever they decide, whatever team decide, accordingly, we'll plan for that. Right? Sir, we have many softwares under AB. What and all we need right now. So right now we need only LogicPro Simulator. As you know that this session is currently live, and according to the recorded video, I'm on a break, but I'm talking to you in a live session. So just after a short break, once we end this query session, we'll go live and start Logics Pro simulation as well as the RS Logics. But I'll clear you each and everything during the main session that uh, RS Logics you can use if you have hardware. If you don't have the hardware, obviously you can't use that one. Although you can use it with emulator, but that is not a sufficient one. So the right now we need only Logics Pro Simulator, which you need to install.
Okay, so
How
let's
can we
start it
get
again,
Siemens
right?
license software?
Let me
So
again
the
share my
license is
screen.
already there. The
I hope
software
each and
package which
everything
I have
is
shared with
clear
you,
to you
if you
guys,
can see it
right?
clearly, the cracked
So
files are there. So you
let's do it
can
again,
install
right?
using,
So as I
you
mentioned,
can install the license using
after
those
this,
cracked
we'll
files.
be directly
While
jumping
trying to
to
install AB
the
on my
software
Windows
part,
11
right?
laptop, I
So
got
I'll
so many
start with
errors and
this
I could not
RS
successfully
Logics
install it.
500,
I just
okay?
wanted to ask if
And
I can still continue with the course
this would
without
be
the
your
software working.
programming software,
Yes, I have
obviously.
repeated this
And
that although
let's
I
try
have
to
provided the
understand how we
solution through
program.
messages and also I have recorded the video just before this session, which I have shared to Telegram and WhatsApp. You can watch those videos to avoid any errors
Okay, so
because
here
if
we
you are
have
running it in
option
Windows
of
11,
file,
obviously you
right?
need to go back
Let's first
to
create
previous
the
version of
new
Windows.
program,
I'm not
and for
asking you
that
to
I'm going
install
to go to
another
file,
version of Windows,
new,
but
and need
run
to
your
choose
software
the
in
PLC.
compatibility mode for
So as
previous
I
version of
mentioned, this
Windows,
is
and
a
the steps
software
are
for
already
too
mentioned
many
in the
other
videos. For now, you can
PLC
continue because
series
we are
of
going to
LL
use
Bedley.
Logics
So
Pro,
currently
and
we are
Logics
working with
Pro will
1001,
definitely work with any
1000, which
version of
is
Windows you have.
basically
Not
based
with
on
Mac OS,
RS-232
but
and
Windows 7,
digital.
8,
So I'm selecting
10,
this one,
11, anyone.
and
You have
Let's
it, so
see.
you can
This one
install
is
it,
a
right?
programming window. This white screen is a programming window, which is called ladder logic
Rajeshwari,
diagram,
I
correct?
guess
As I mentioned,
you are
ladder
not able
logic
to
diagram mean
open
the
the RSLinks
steps
software.
or
I need to
the
check whether
stairs,
you
right?
have
So
installed the
if I show you
license
this,
and
look at
license
this.
or not.
This one is
So
the option to
let's for
create the
now, although
ladders. This one is
I have
the
repeated this many
instruction
times that
palette.
we have
This
to
one is
use the
called
LogicPro.
instruction
So I
palette. There
recommend
we
you to
have too
please
many
continue
symbols.
watching the
I'll let
video
you
till
know each
last.
and every one.
Uh, I mean
First,
live
I'm
session till
starting with
last,
this
and
one. That is
I'll try
your
if we get the time. I'll share the
new run
Zoom
or
link
new
with you
line
guys
or
so
new
that
ladder or new
whatever
row, whatever
questions,
you
whatever
say,
problems
right?
you have, we
So
can
if
share
you
with the
tap on this, you can
audio
create
sharing. And
many
also,
ladders,
I'll try to
right?
handle your
And
screen to
this
check
is
what
ladder
kind of
logic,
license problem you
right? So
have there on
here we
site.
have to create the program where this input side is, this left side is reserved for inputs and the right side is reserved
That's
for
fine if your Siemens
outputs,
is
right?
working, you can
Now,
use it,
what is
right?
this? This one is to connect
We can't get a
two
copy of
inputs in
pre-recorded
parallel or
videos
two
for now. It's
outputs
not
in
allowed from
parallel,
the company
right?
side.
Before
Sorry for
we
that.
jump to
The
these
videos
two
on how
symbols,
to install
first we
LNBedley are
need to
not supported on
understand
my
few more
PC.
things,
Watch the
right?
video on the
In
phone then.
categorizing the push buttons,
Mobile phone you have.
as I said, for training
If you
purpose,
are
I
unable
have
to
choose to
download
push button
LNBedley even
based
after
PLC.
following the guidelines on the video,
And I have
try to
another
download it from your
version
mobile
also
phone. It
available with
would be
me. I'll
possible
try
that you
to
can't
have
download
that
it.
one
I have
also
tried it
there.
from
Okay.
many
So push
devices.
buttons
Whatever
are
things
basically
I'm
what
sharing, I'm not
we
sharing on the
have
basis of
different
only my
categories
device
of
because
push buttons.
as a
Direct,
tutor, as a trainer, I have
toggle,
been in this field
and
since 13
then
years. So
set,
I'm like looking at many
reset,
devices, helping
and
students install it,
reverse.
right?
These
So
are
please try.
four
Otherwise, let's
categories of
connect in
push
the Zoom call.
buttons, right? Or let's say buttons only, right? So direct category is
No,
what?
actually, I'm not. I have not. I mean, I have not
Direct
shared
inputs,
microwave
direct
simulation
buttons are those
simulator
buttons
software.
who
But
give the
yeah, if you want,
output
I can
till the
share the
time
link
you
for
hold
that
them.
also. I have that.
Look at this. If I push it, it works, right? If I push it, it works. But if I release, it come back. This is called direct input. Another example, the doorbell, the horns of your vehicle,
Two voices are playing. Let me check
all the
why it's
keys
happening.
of the
Just wait
keyboard.
for a second.
These are direct categories. Till the time you hold, it give output. Otherwise, don't give.
Yes, so now you won't be able to hear two voices. Actually, as I said, I was on the break for that recorded session and it was started on the back end. I just paused it now, right? So now you won't face these two voices overlapping and all. Let's come back to your queries again. Microwave simulator software. I'll share the link as I said. Okay. Yes. The class video was started. Thanks for the update. If you need TIA portal license, connect with me later. I'll share it. No problem. I have that as well. Okay, I guess all the queries have been solved. So now I'm again starting the technical session, the main session, and we'll meet again for the doubts if you have.
Okay. So here we have option of file, right? Let's first create the new program, and for that I'm going to file, new, and need to choose the PLC. So as I mentioned, this is software for too many other PLC series of LN Bedley. So currently which is basically based on RS-232 and digital. So I'm selecting this one. And let's see, this one is a programming window. This white screen is a programming window, which is called ladder logic diagram, right? As I mentioned, ladder logic diagram mean the steps or the stairs, right? So if I show you this, look at this. This one is the option to create the ladders. This one is the instruction palette. This one is called instruction palette, where we have too many symbols. I'll let you know each and every one. First, I'm starting with this one, that is your new rung or new line or new ladder or new row, whatever you say, right? So if you tap on this, you can create many ladders, right? And this is ladder logic, right? So here we have to create the program where this input side is, this left side is reserved for inputs and the right side is reserved for outputs, right? Now, what is this? This one is to connect two inputs in parallel or two outputs in parallel, right? Before we jump to these two symbols, first we need to understand few more things, right? I'm categorizing the push buttons. As I said, for training purpose, I have chosen a push button based PLC. And I have another version also available with me. I'll try to have that one also here. Okay. So push buttons are basically what? We have different categories of push buttons: direct, toggle, and then set, reset, and reverse. These are four categories of push buttons, right? Or let's say buttons only, right? So direct category is what? Direct inputs, direct buttons are those buttons who give the output till the time you hold them. Look at this. If I push it, it works, right? If I push it, it works. But if I release, it come back. This is called direct input. Another example, the doorbell, the horns of your vehicle, all the keys of the keyboard. These are direct categories. Till the time you hold, it give output. Otherwise, don't give. Toggle. Toggle inputs are what? You just need to tap it once to get continuous output, right? I have a selector switch here, right? This one. If I, this one, yeah. So if I keep it like this, it is not coming back. If I keep it like this, then it is coming back, right? All the buttons, all the control buttons basically, which you have for your home appliances to turn on the lights and turn off the lights or fans and all, those are what? Toggle inputs, which you simply tap one time to continuously on, then other time to continuously off. Category of toggle inputs, right? Set reset is a button of two pairs. Set reset is a button of two pairs. Let's say button A and button B. Button A we always use to turn on and button B we always use to turn off. That means what? We cannot use the button A to turn off and button B to turn on. They have specified and fixed task which they can do. Now reverse are what? Again we have two buttons A and B, but with the help of button A we can on and off. With the help of B also, we can on and off. Let's say two-way switch. We have a bulb, we have a lamp, and in the gallery, okay, and the that lamp is situated at the center, and then we have two controls to control that lamp on both sides of that gallery, at one end and other end, right? So you can on from this end, off from this end, on from this end, off from this end, on off, on off. You can do anything you want, right? Category of reverse switches. Now I'm going to initiate with direct switches. Okay, I'm going to initiate with direct switches. Talking about this one, it has two different categories, NO and NC. Same for toggle. NO is called normally open. Normally open. And NC is called normally close. So we have two different categories. Normally open is what? Those buttons which are open in normal position by name. those buttons which are closed in normal position called normally closed. Let me give you a few symbol examples. So this one is a normally open according to your software, and this one is a normally close according to your software. But if I tell you according to the direct and the toggle, so according to direct, the symbol of normally open is this one. It has a spring, so to come back, and according to toggle, it has a symbol like this. Then NC, according to software, the symbol is this. According to hardware, direct, the symbol is like this. And according to toggle, hardware, the symbol is like this, right? So let's start giving the current from input side. And let's consider all at their initial position. The position is zero position. All has the same position, that is zero position. But we are giving the current to all the inputs. Okay. Now in this case, we may see the open circuit. So we know we are not going to have any output. So output is zero. So when you don't push the button, the output is zero. When the buttons are in initial position, it is normally open, output is zero. Same case, zero output. But in this case, you get the output because it is closed. So whatever current you pass from here, you will get here. Okay. So this way you get one output, and at this time you get one output again because it is also closed. Same here, it applies zero position, zero output, zero position, one output. Position is zero, but we are passing the current. Remember what I'm saying. Position is zero, initial position, but we are passing the current to both the inputs, right? Now, if we push, make the position 1. Make the position 1 mean final position. Same here, make the position 1, make the position 1. So if we push the buttons, this button is going to close, this one is also going to close, this one is going to open, this one is going to open. If it get closed, obviously it will give you current output side, closed circuit, it will also give you current, it won't give you current, it won't give you current. These two will give you current when you push because they will get closed. These two won't give you current on the output side because they'll get open. So that is the category of normally open, direct and toggle, and normally close, direct and toggle. So what we get in the case of normally open, the logics are what? 0 is 0 and 1 is 1. And in the case of normally close, 0 is 1, but sorry, 1 is 0. 0 is 1 and 1 is 0. So with open is called active high because it is turning high when you active this. And NC, normally close, is active low because it is low when you activating this. I hope it is clear to you. I'll repeat. Normally open is 0, 0 and 1 is 1. Normally close, 0 is 1 and 1 is 0, right? So now let's come back to the software again. So these two symbols, which I was talking about currently. So this one is for NO and this one is for NC. And this one is for coil symbol. This one is for coil symbol. Let me come back to this one again. Okay. Now what we have to do the ladder logic diagram, right? And this way we have ladders. The left side is reserved for input. So these two symbols are for inputs, NO and NC. And this one is the coil symbol, output symbol, right? So you can place these two symbols on the left side, this symbol on the right side. If you place this symbol on the left side, it will give you error in the programming. If you keep these two symbols on the right side, it will give you error in the programming. Other than that, if you want to keep two inputs in parallel, this one is symbol. If you want to keep two outputs in parallel, this one is the symbol. That means this is the symbol which you can use in both the sides, input as well as output. So this one is input side and this one is output side. Make sure whenever you do programming, you have a rung. Without rung, you cannot program it. Okay. So rung is a new line, a new ladder, a new stair, a new step. Okay. In language of Delta PLC, it is called row. When we do Siemens, it is called network. So with other different brands, we get different what? Different names, right? That's it. Now we'll come to software again. So suppose if we want to keep, let me start with the very first line. Okay. Yes. So I'll have a rung. I'll select the rung. If you select it, you can see this selected now. Now, if you want one input and one output, simply tap here, simply tap here. Okay. Then you need, suppose, another rung, click, and one NC input, one coil input. So this is your NC input and this is your coil output. Then you need two inputs in series. Just tap two times and get a coil. You need two NC inputs, so tap two times and a coil. If you need one NO, one NC, this way you can do it, right? If you need a two NO and one coil, and after this, suppose you forgot to apply one NC with this. So now you want to apply one NC in between these two NO. I'll repeat what I said. You created short program with two inputs NC and one coil, but you want to keep one NC as well between these two NO. And if you now tap on this NC icon, what will be there? NC is connected just after the coil, which means the coil is now on the left side, which may give you error in the programming. Not which may actually, which will give you. Definitely it will give you error. So how we can solve this problem? See, whatever instruction you apply here in this software, it applies just after your selection. Let's see. Once you select this, click NO. So now NO is selected. Now click coil. So coil will be applying after your selection, and selection is what? NO. So if I click on the coil now, so it is applied after a NO, right? Now, if I keep NC and then coil, so coil will apply after NC. Now, same way, we did what? We keep two NO and then coil. So now the selection is coil. If you tap NC after the coil, obviously NC will connect after the coil only, right? So, and we don't want this because it's an error and we want it between these two. So select this one. Now click NC. Problem is solved. Another way to solve this is what? Simply tap and hold and drag your mouse. Tap, hold, drag your cursor. Once you see the green color, wherever you want to drop, just drop it. Once you see the green color around where you want to drop it. Okay, I'll do it again, right? With a different style. Now, suppose I'm not keeping this way. I want to drag and drop each and everything. So let's drag. Now let's drag green color. Now let's drag coil green color. Now let's drag NC green color. If I drop it, if it is not green, it's not going to apply there. Got it? Now, if you want to have two inputs in parallel, simply select parallel, select here, click NO, select here, click NO, select here, click coil. So in this way, two inputs are in parallel. If you want three inputs in parallel, select parallel, NO, NO, keep them, drag them here. This is the another way to connect in parallel. And then select this one, another parallel, drag it to right side, select this, now NO. So this way to have three parallel, right? And if you want to delete it, simply select delete from the keyboard, or otherwise you can do right click, cut, right click, cut. So it's your choice how you want it, right? So this was the short introduction of how we use this UI. Right now, I'll use one NONC, one NO coil, whatever you want. But have you noticed one thing? Whenever we start with any input, we have a question mark. Here we have a question mark. See, when we're talking about the hardware, right? When we're talking about the hardware, look at this. We have six inputs and we have four outputs, correct? So obviously, whenever we work with the hardware, obviously this PLC need an input from your side, that which input button or which input sensor you are using, because we have six. So you need to mention in your program, you are using the first one or the third one or the last one. So for that, we need addressing methods. For that, we have addressings, right? So now we need to understand about the addressing methods. That is called data files. And these addressing methods may differ from PLC to PLC. Currently, I'm telling you according to Ellen Bedley. Later, once we'll do Siemens, obviously we need to change each and everything according to that. Okay. So first, I'm going to tell you about data files from Ellen Bedley. And the first file is called input file, where address of inputs are I:0.0/02, I:0.0/15. And then the second one is output. This is the addressing method of your Ellen Bedley. Okay. I'll explain you each and everything. Don't worry about that. O:0.0/02, O:0.0/15. Okay, there are too many data files other than that, input and outputs, but currently we are starting with input outputs. So let's don't take too much of headache. We are starting with these two only. Okay, other files are like timers, counters, control, integers, float, binary, too many things are there, but we'll be discussing once we reach to that point. Okay, so now let's focus on this I:0.0/0, and let's try to understand what is the meaning of this. So here I:0.0/0. In this zero, I is what? I mean input. I mean simply input. When we're talking about this I mean input. Then this is colon. Colon is basically a separator which is separating alphabets from numerics. Then this zero is your slot address. This zero is your word address. And the last zero is called the bit address. Okay. I input is clear, separator is clear. Now, what is the slot? Like we have slots in our mobile phones for the SIM cards, the same way PLC also may have slots to extend the number of input outputs. Like in my PLC, I have 6 inputs and 4 outputs. But in an application, suppose if I need 10 inputs and 4 outputs, or 10 inputs or 8 outputs, if I have an option in my PLC to increase the input output, I can connect one extension module with it if it has an option. So whenever you have an option, you can increase your input output, but in that case you need to change the address of your slot, right? For example, if in your phone you have a single slot for the SIM, no options are there to extend. But if you have 2 options for the SIM slots, they have their port numbers: SIM slot 1, SIM slot 2, right? So if you are connecting your SIM at slot 1, you need to address it. If you're connecting at 2, you need to address it. Same way, here also, whenever we use the input and outputs of default slots, it is 0. Once you increase it, it is 1, then it is 2, it is 3, depending upon how many slots you have. Then word and bit. So to understand this, we have a very simple relation according to the computer. That is, one word is equals to 16 bit. One word has 16 bits, right? That is why if you notice this, the address started from 0 to 15. 0 to 15. How many counts? 16 counts. So one word has 16 bits, right? So if we have to write the address, I guess it is clear to you, right? Now, what we do with the word and bits, that we are trying to understand. So whenever you need to write the address, always you have to change the bit address. And once the bits are completed till 15, you can change your word address. Let me give you example for this, right? Let's come to this. Suppose you are writing the address for your very first input, that is I1. Okay. So the address of I1 is I:0.0/0. Okay, I'm initiating it with the very first bit, that is 0. If you have to write the address of I2, it is I:0.0/1. Then I3 is I:0.0/2. So I'm starting with 0, 1, 2, I'm changing, right? So randomly, if I have to write it for I10, it would be I:0.0/9. See, when we started for the first input, it was 0. Okay. When we did it for 2, it was 1. 3, 2. The same way, if it is 10, then minus 1, it is 9, because we're starting from 0. Okay, so we have to always subtract 1. If we have to write the address for I16, it is I:0.0/15. Okay, and suppose if you write the address for I17, and if you write I:0.0/16, so it is wrong. Why it is wrong? Because at max, we can go up to 15 only, because one word has 16 bits. So 15 was maximum. That does not mean that you cannot write the address for I17th. Okay, let me give you a look of another PLC. I need to stop sharing. right? So if you see this one, right? So it has around 20 inputs and 12 outputs. 20 inputs, obviously more than 16. So when we start writing the address for that PLC, what we need to do? We need to change the word address, right? So let's come to the point. So I does not mean we cannot write the address for 17 in this PLC. Micrologics 1000, we have only 6 inputs, which is very clear. I1, I2, I3, I4, I5. Starting from 0 to 5, it is done. I1, I2, I3, I4, I5, I6. Starting from 0th address to 5th address is done. But when we talk about another PLC which has more than 6 inputs or more than 16 inputs, how we write the address? For I17, I colon 0 dot, not 0 this time, it is 1, because now we need to change the word address. Okay, and 1 slash what? 1 slash 0. We'll start with 0. And then I18 is what? I colon 0 dot 1 slash 1. Randomly, if someone asks you I32, so it would be I colon 0 dot 1 slash 15. 1 slash 15. Okay, so let me tell you how we identify the address for this. Randomly, suppose if I have to calculate the address for 67. Okay, what is the address of input 67? How we can write? Divided by 16. If you divide it by 16, it goes 4 times. 16 fours are 64 and remainder is 3. How we write the address? I colon 0. I mean input, colon means separator, 0 means slot address. Up to this, it is fixed for now. Okay, dot. Now we need what? This one. This one is what? Word address. So look at this. The word address is here, 4. And this one is a bit address. Just do one thing. Whatever remainder you get, -1. Do it, -1. 3 minus 1 is 2. So it is I colon 0 dot 4 slash 2. So this is the way to write the address. Okay. And if you want to verify, it is very simple. 4 mean what? 0, 1, 2, 3. Already 4 words are completed, and this one is the 5th word because we start from 0. So it is 5th word. 5th word mean 4 words are already done. One word equals to how many bits? 16 bits. So 4 word will have how many bits? 16 cross 4 plus 2 bits we have written here plus 1 we reduce, 1 we subtract. So now if we verify, it is equals to 77. I hope it is clear to you. I'll do one thing. I'll take another example and then let's see if you understand this also. So now let's calculate for 98. Okay, random number 98. So let's divide it with 16. 16 6 are 96. Remainder is 2. So let's write the address I colon 0 dot 6 slash 1. Is missing. We have subtracted 1 from the remainder and we mentioned the word address as it is. If we have to verify this, now 16 cross 6 plus 1 plus 1. Why I multiplied this with 16? Because 0 to 5 already 6 words are completed and one word has 16 bit. So 6 word has 16 into 6 bits. Plus 1 we have mentioned here. Plus 1 we minus 1. We do subtraction. So we have to add 1 as well. So it is now 98. So this is the way to find out the addresses, right? Now let's go further. For now, we need only how many inputs? 5 inputs, right? So what are the address for those? I colon 0 dot 0 slash 0, then I colon 0 dot 0 slash 1, then I colon 0 dot 0 slash 2, 6 inputs, not 5. So I colon 0 dot 0 slash 3 and I colon 0 dot 0 slash 4 and last but not the least I colon 0 dot 0 slash 5. So we have these 6 inputs in my PLC, right? And also we need to mention which one is a category of direct NO, toggle NO, or what we have. So the very first input we have as a toggle button, toggle NO. The second button is direct. All the other buttons are direct. So I'm writing it only once, direct, but this one is NC. Then it is NO, it is NO, it is NO, it is NO, it is NO. Okay, I'll come to the big screen for you. See, green color indicates NO. Okay, industry standards. Red color indicates NC. Starting from here, this one is toggle. If I change the position, it's not coming back. So toggle, I need to make it again. But this one is direct because if I push it, look, if I push it, it's coming back again. So have a spring, and then same. But this one is NC. So starting from here, the first input is toggle, second is NC, NO, 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 NO. Right now, in my case, I have done this to understand each and every button. I recommend to learn your PLC programming with all category of buttons, because if you start learning your PLC programming only with toggle button, it is very easy. It is very easy, but at a result, you won't be having too much of experience to solve too many problems of industries. That's why I recommend to use each and every button, right? Also, this is another category of button is called emergency button. Push, right? But if you want it to come back, you need to rotate it. It is a category of emergency button. But in this PLC, I have toggle NC, NO, 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 NO. Okay. Now, as you can see, the kit is already ready. The wiring part is already done. So we cannot change the NO to NC or NC to NO, which mean what? These address are fixed for now. I colon 0.0/0 is for toggle. Let me share my screen again. So these address are fixed for now. That is what I colon 0.0/0 is for NO toggle. Then I colon 0.0/1 is for NC, and then rest 4 are for NO. So for now, we cannot change the address. These are fixed that we will use NO with these 4 address, and we'll use NC with this only one address, and we'll use toggle with this only one address, right? Further, if we want to change it, we can do it, but we need to change the wiring. Okay, we need to change the wiring. We just need to replace the buttons and the wires, and that is done, right? So it is not fixed with every PLC that you will take 4 NOs, one NC, one toggle. It's completely your choice where you want to have NO, where you want to have NC, how many NO, how many NCs, right? You may have all 6 NCs, you may have all 6 NOs, you may have all toggle NOs, you may have first NO, second NC, then toggle, then NC, then NO, any combination, but that you have to decide at the time of wiring. Once the wiring is done, your addresses are fixed. Got it? Now, the outputs. If you look at this, and if you look at this, only one small change, I to O. I mean input, O mean output. So let's come to this. We have 4 outputs. So I'm fixing it O colon 0.0/0, O colon 0.0/1, and then O colon 0.0/2, and the last O colon 0.0/3. And these 4 outputs, how we have these 4 outputs? Let me come back to the PLC again. So O colon 0.0/0/1/2 and /3. 4 outputs. The blue color LED, green, green, and then red. On all these are 24 volt DC operated. If you want to connect motor of 24 volt, or if you want to connect a pump or a valve 24 volt operated, you can do it. But if you want to have 3-phase motor, you can't do it directly. In that case, you need what? I've already mentioned drive. Very nice. So in that case, we need drive. Now, let's come back to the programming again. So whenever we start programming, we need to mention which input I am going to use. So let's say I'm creating a small program that we have a one input and one output. So if I connect I toggle input. So I colon 0.0/0. I'm writing the address here. How I write it? Simply double tap on the question mark and write your address. O colon 0.0/0. So for now, what I did, I'm using this input, the toggle input, very first input, and this blue color LED. I'll check if I turn this on, it should be on. If I turn this off, it should be off, right? So the program is almost done, right? We need to transfer this program from our PC to PLC. We need to transfer this program from our PC to PLC. Now I mentioned this thing, if you remember. Connecting the cable is not enough. We need to communicate as well. And for that, we have another software, RSLinks, right? Also, your cable current cable which we are using is PM02 DB9 male female USB, and we have too many USB ports available in our PC, which is called basically communication ports. I'll repeat what I said. We have too many USB ports in our PC. We have too many USB ports in our PC, and each has a different communication port number. How we check it? Simply go to the search bar. This one is the search bar. And right here, what device manager. So if I go here to device manager, you'll be able to see the ports. And their ports, you have USB serial port COM4. So whenever you connect the cable with your PC, if your drivers are installed, it must show you the communication port. Okay, so currently it is showing port number 4. Now let's do the communication part with which software? RSLinks. How to do that? Let's start it. I'm starting with RSLinks classic software. Double tap. It will ask you to start. So simply click start. Let's first go to communication option. There we have option to configure the drivers. Simply go to this option. If you see already a driver is running, then you need to stop and delete. Create your own driver. How to create? Simply go to available driver types. You need to select the cable which we are using. For now, it is RS232 DF1, DF1 mean full duplex technique, and click add name. Now it will show you the name of the driver, that is Ellen Bedley full duplex 1-to-1 communication. Click OK. Now here we see COM ports options. So I'll check with COM4 and click auto configure. So now it will start communicating with PLC. It will give some info to PLC, will receive some info to PLC. If everything goes fine, it will show you the message like this: auto configuration successful. Okay, let me show you another case when it may fail. If you don't connect the cable, or if the supply is off. So let me turn off the supply. I have turned off the supply. Now if I go for auto configure, it will show you the error message, failed. It will take some time to get the failed message because currently it is transmitting the signals to PLC, and then it will get back to it. So it is not getting any signal back. So it means failed to find the baud and parity. Okay. Now I'll turn on the PLC and I'll repeat all the steps which I have done right now. I'll close the software, restart the software so that you can see what we have done to communicate. Okay. If you know like what I have done here, but whatever I am doing before me, just start telling that what we have to do next. Okay. So first of all, let's open RSLinks Classic, go to Start, then Communications, Configure Drivers. I'm saying slowly so that you can recall. Then Available Driver Types, RS232, Add New, click OK, select COM port number. As mentioned in Device Manager, it was 4, Auto Configure, and it is successful. Okay, close and minimize. Right now we are done with the communication part. We need to check this program. Simply let's go to this option. Here we have download. Here we have download. Okay, this one is the download panel. So now it is asking to save. I saved it with the same name, saying this file already exists. Replace. I said yes. Downloading program to this bulletin, Micrologics 1000 to this. Are you sure? Yes, obvious. We are sure. So it is now transmitting the code. Let's wait for the code to transfer. So the code is already transferred now. Let's go to online. So it is saying that now your software is online. If you want to monitor from here also, you can do it. Okay. But PLC is in programming mode. Okay. We need to make it to run mode. So let's come here and make it to run mode. Now your PLC is in run mode. Okay. I'll stop sharing my screen for a sec. Okay. Now look at this. This was the input. This was the output, right? So if I keep this input on, see the output is on continuously because it's a toggle button. If I keep it off, the output is continuously off as it's a toggle button, right? Now again, come back to the PLC, right? So I mean to programming software. See, now I'll do it again. So you can monitor it using your software also because software is in online mode. Software will show you the current is passing through the green colors. This input is passing the current. This output is on. If I keep it off, So the output is now off. I hope you understood this one, right? Now, again, if you want to edit the program, simply go offline. If you go offline, if you turn off the system, if you remove the cable, that does not mean that PLC program is not going to respond, because PLC already has that program, so it is going to work. You have seen that I went to offline, but still the program is running. Okay. If you don't want to if you don't want program to run, you need to come to programming mode using the software. How? Go online, make it program mode. So now when it is blue color, something like that, now the program is not going to work. Look at this. Okay. On the right side, you must see my face in the PLC. So I'm not switching the screen for now, just doing it. It's not working, right? Now let's go to offline mode to create a new program. This time I'm going to use the NO address. Okay. This one address, open address, direct button. Okay. So I change this to 2 and nothing else. Let's download it again. Wait for downloading to done. And do you want to go online? Yes. Make the PLC to run mode. Okay. Now I'll stop sharing again and look at this. So now I need to push this button. This was 0. Then it is 1. It is 2. This address we have used. So if I push it, output is on. If I release it, output is off. Again on, off, on, off. So till the time I hold the input, the output is on. If I release the input, the output is off. Category of direct input, right? Come back to programming again. Now, if I change this address to 1, which is a NC, because NO has a property of 0 is 0, 1 is 1. But NC is a bit different. It is 0, 1 and 1, 0. So let me download again. I've changed this to another address, that is 1. So till now we have created 3 programs, okay, with the hardware. Just after this, I'll show you how you can practice with the simulator, which you already have, right? So this time, if you see, I'm not switching the screen, but look at this, the output is on, right? And if I keep this input on, this one, I1 is this one, the red one. So the output is off. Input on, output off, input off, output on. Just opposite, 0, 1 and 1, 0, right? Now let's go to offline. Now is the time when we need to also understand about the simulators. Okay, so let me open the simulator LogicPro, because you may practice with this very easily for all those programs which we are doing for now. So let's have a look on this. It is same like your RS logics, NO, coil, NC, coil, same fundamental. Okay, but this we already understood, so I'll not repeat these things. Let's create a simple program. NO. Now about the address. Okay, see, this simulator does not belongs to RS logics, so it may have a bit different functionalities. So now I'm writing the addresses for simulator. So when you're working with the simulator, you need to change the address a bit, because it is starting from I:1/0. Then it has I:1/1, I:1/2, I:1/3, I:1/4, I:1/5. These 6 inputs we have. And for outputs, we have O:2/0, O:2/1, O:2/2, O:2/3. Okay. Why we have the address a bit different? Because now it's simulator and it is not related to the original software of RS Logic. So it has changed a few things, right? Excuse me. So if I go to simulator, on the top, we can see the simulations option. And there we have input output simulator. Okay, how to open this? In this menu bar, we have second option of input output simulator. This one, second one. It is there. Okay. Now, whenever you install, For very first time, all the inputs are in this way, which I'm doing for now. So by default, all the inputs are toggle inputs. It already has 32 input outputs in this simulator. Starting from here, I colon 1 slash 0 to 1 slash 15, 16 inputs. Then I colon 3 slash 0 to 3 slash 15, 16 inputs. Another 16 inputs. So 16 plus 16, 32 inputs. Then if we talk about the hard outputs, O colon 2 slash 0 to 2 slash 15, and then O colon 4 slash 0 to 4 slash 15, right? 32 inputs and 32 outputs. But we have to work according to the hardware where we have only 6 inputs and 4 outputs. So that is why I mentioned only 6 input address according to simulator and 4 output address according to simulator. And what are those? This one. Look at this. When I place my cursor here, it is showing you the address I colon 1 slash 0, 1 slash 1, 1 slash 2, 1 slash 3, 1 slash 4, 1 slash 5. These 6 inputs. And outputs O colon 2 slash 0, 2 slash 1, 2 slash 2, 2 slash 3. I understand when we work with simulators, when we work with hardware, it is quite difficult to understand each and everything at the same time, and it may be confusing, right? But I strictly recommend you guys to avoid all other videos from any other source. If you are joining this session and if you are assuming that I'll be training you, so just depend upon me only. Okay. As I mentioned, for any doubts, I am here. I'll be clearing your doubts. But if you take another source, another video to understand, you'll get completely confused. I understand it is already confusing and PLC is quite difficult when we start. But once you go through about 2 hours of the session, after this, it is very easy to understand. And trust me, I'm giving you this guarantee, like I'll clear each and every concept and you will be learning in very nice and smooth manner. But you don't have to follow any other chat GPT, Google, or any other video source for that. You need to trust only one, and that is me for now. Okay. So just revise whatever we are doing here, and it will clear everything. And then if you have any doubts, we'll come to the live sessions with the Zoom or other platforms. Okay. So this one is I colon 1 slash 0, 1 slash 1, 1 slash 2, 3, 4, 5. Till here, we have to use only 6 inputs. And O colon 2 slash 0 to 2 slash 3, we have to use only 4 outputs. Although we know that we have too many inputs here, 32 inputs, but we have to use only 6 inputs and 4 outputs. Why I'm doing this? Because my hardware has only this much option. Now the point is, if you say why only 6 inputs your hardware has, so why do we have restrictions? Because I have one another concept behind it. See, whenever we have to work in industry, it is also important how to make a product with low cost. Suppose if you start learning with 32 inputs and 32 outputs, it will be in your habit to use extra inputs every time, extra outputs every time. So whenever you have to make a small application, you will be demanding a large size of PLC, which may cost higher. But if you learn with limited resources like this, only 6 inputs, only 4 outputs, and we have to create a lot of programs with a lot of applications and requirements, that's how we can cut the cost. That's how we can reduce the cost. So that is my concept of teaching, that when we start with limited resources so that you can keep your practice very good, so that once you complete the things, you may do any program with limited resources as well. Getting my point? That is why I suggested one more thing, to have all inputs, NO, NC, toggle, so that you can learn with all three type of categories. Right? Let's come to this. Now, if you see the first input, it is a toggle switch. Toggle. I already told you the symbols of the toggle, NO, NC, direct, and all. So this one is the toggle, right? But according to the PLC, which we have for now, the very first was what? Toggle. Then second one was NC. Then all other was NO. So we have to make it according to that only. And how we can change this? Simply right tab to change the property of your button. Okay, the first one is toggle, we not need to change. Second one is required NC. So right tap, it is now NO. Again right tap, it is now NC. Right tap till the time you achieve your desired input. Okay, now next four we need as a direct NO. So right tap only once. So now we have set the first input to toggle, second to NC, third, fourth, fifth, and sixth to NO. And after this, avoid using right tap. Never ever change this right tap because now you have fixed the inputs. You have fixed the wiring and you are not going to change the wiring. So you are not going to change the symbols here as well. Okay. If you have to check how inputs are working, you have to tap left. See, I apply the action through left. If I hold it, it is giving output. If I release it, coming back. This one is toggle. So you not need to hold, simply tap. It's holded already. Tap, coming back. This one is NC direct. So you need to hold it. Again, if you release, come back. Okay. Now let's come to very first program, which we did with the hardware. So the first program was we have an input and an output and a toggle address. Toggle address is what? I:1/0. I understand remembering both the address at the same time is quite difficult, but if you have to practice with simulator, remember the address of simulators for now. Once you move to the hardware, just reopen this video, okay, and then check what address I told you, or reopen your notes if you are creating, so that you can see what are the actual addresses of inputs if you use it with the actual software, RSLogix or original software, right? So now we'll be learning through simulator so that you can practice in a good manner at your homes as well. So I:1/0 is your first toggle input, which I have used, and O:2/0 is the output which I have used. As it's a simulator, so obviously PLC is not required. This is going to act as a PLC. This is going to act as a software. Now let's download the program from this PC or this software to this hardware. When you do RSLogix, you were having the option here, right? Let's do it. Same, download it. Now go online. It's now in online mode, but it is PGM mode. PGM mode means programming mode when you are programming it. So make it run mode. Make it run mode. Now your program is in run mode. Let's tap the input. If your input is high, output is high. If you release it, look at this. I'm not holding the input because it's a toggle. It's already holded. If you keep it off, again tap off. Right? The first program we have created. Now come to second one. Let's go offline. And the second program was with NO. So let's make it 2 because NO address is 2. Right? Now again go online, download to PLC. First download to PLC, then go online, then make it run mode. And now if I tap this, I need to hold it to get continuous output. If I release, the output is off. So 0 is 0, 1 is 1. 0 is 0 mean when you don't push, output is 0. When you push, output is 1. So 0, 0, 1, 1. Now let's come to offline again and change the address to I:1/1, which was your NC. And now if I download it again, download to PLC, and then if I go online, see, I'm not pushing it. Even you can see here, it is in the normal close position, initial position, current, it is passing, output is on, right? And if I push it, the output is off. So at 0, it is giving you 1. At 0 position, initial position, it is giving you 1. And when you push it, it is giving you 0. Right? So that's how we have done 3 programs with the hardware and 3 with the software. Now again, take a pause. Let's discuss about the doubts and whatever questions you have, ask me and then we'll continue further. Okay? Take a pause. Think about whatever we have done. Take 2 minutes of time to think and then we'll proceed further if you don't have any doubts. If you have doubts, ask me in the comment box.
Okay, guys. So I'm again live for your doubts. If you have any questions, please let me know by WhatsApp. I mean, sorry, by commenting. Okay, I have few questions to answer first. Sir, if the toggle switch has three modes, then how will the addressing be? Okay, if toggle switch has three modes, then obviously it will have three wires as well. I mean, 3 points where we connect the inputs, right? So if you connect one at I colon 1/1, other at I colon 1/2, and other at I colon 1/3. This way you can connect, right? So it's completely your choice where you connect because at your PLC, currently talking about the same version which we are talking in the main session, live session, that is Alan Bedley Micrologics 1000, 24-volt DC input and six outputs and four outputs. So if you have six inputs, so you have only six pins in your PLC. If you take one toggle with three modes, then obviously three inputs are occupied with the same toggle button. Yes, tomorrow we'll have Siemens, obviously. We can use memory also in AB. Just wait for a sec. We'll be coming for that as well. Okay. I'm not sure about the recording as I said earlier, so please wait for that. How to off the process? I didn't understand what you're actually saying, Rajeshwari. Any other doubts? Please let me know. Any other questions? Please let me know. Communication cable name. For now, I'm using serial cable, which is RS232, which has two sides. The one side is basically the PLC side where we use PM02 connector, and other side we have is the system where we have USB connector, and in between we have DB9 male female connector. When we use Siemens, there we have basically PPI or MPI cables. Yes, obviously, at Brain, we already I already mentioned this thing that you can practice using the LogicPro, and that's what I'm doing during the live session. As a fresher, how I started my career in PLC automation. Can you guide me? I'm electrical graduate. So, Mr. Bhaskar, obviously, first you need to learn about the PLC, SCADA, and other tools of the automation if you want to build your career in the automation industry. And once you are done with these things, you may apply through either LinkedIn or I also have job and placement groups for my students, especially where I regularly post requirements of pan India basically. I don't have requirement from other countries except African countries because I do have too many African clients as well as too many African students. So they do share the requirements with me, which I post with my students on regular basis for industrial automation and others as well. Thank you, Mr. Narendra Mohan. Thanks. Thank you, Jivatma. Thank you, Sai Ganesh. Sai Ganesh, yes, for HMI, we have different software, not this one. Sir, once the program will run, then how to turn off the program? See, we have three different modes of programming. The first mode is offline, right? When you are editing it. The second mode is online, like online bin run mode. So if you downloaded the program and you want your software to be online, you need to go to run mode, and your PLC also will be in run mode in that case. But if you don't want your program to be in run mode, you want to off the program from the PLC and as well. So you need to switch it to remote program mode. Remote program mode. These options are available in RSLogix. When I'm talking about Logix Pro Simulator, there you have options of download, then go online, that is called run mode, and go offline, that is called PGM mode, programming mode. Which one software we use? I'm showing all those things at Razi that we use RSLogix 500 to connect
Okay,
with real
let's
hardware, which
continue. I
I'm
guess
doing at the same
now
time,
all the doubts.
right? And for simulation using Logix Pro. Yes, Brain, you can use Logix Pro Simulator to practice. Okay. And later, if you want to learn from, yeah, later, if you want to practice with RS Logix 500, then you can install the emulator, which is already being shared in the package. Yeah, sure, Rajeshwari. See, input-output simulators are basically to check the physical inputs and outputs of your PLC. So in the case of simulation, you have input-output simulators only, not anything else, right? I mean, to check the inputs and outputs, we have input-output simulator. So if you see there, we have around 32 inputs and 32 outputs, right? And you can use all those inputs, 32 inputs and 32 outputs. But currently I have made the scenario according to the hardware, which has already 6 inputs and 4 outputs. So I equivalent 1/0, 1/1, 1/2, 1/3, and 1/5. These 6 inputs we are using, and O colon 2/0, O colon 2/1, O colon 2/3, and O colon 2/4. Four outputs we are using. Otherwise, you have around 32 inputs available in this simulator. As I said, we need to learn with limited resources so that we can create the program for industry with limited resources as well. Once you understand about the basic concepts, generally I say once like when I teach to my students about this PLC program in the duration of around 120 or 150 hours, so around 20 hours. After 20 hours, I ask them to use n number of inputs, n number of outputs as per the requirement, because now you already understood the basic, the concept, like how many number of inputs we have, how we have to use them, what are the requirements. According to that, how we can finalize how many inputs to be used, how many outputs to be used, right? So once they complete 20 hours of training with me, then I ask them to use n number of inputs as we want, as per a requirement. Brain, I'm going to have a live session after this. Live session, I mean, this is also a live session, but we'll have another live session with the Zoom so that whatever doubts you guys are facing, we can resolve them. Okay. Sure, I can provide you some logics as well for the practice if you want. Just remind me on Zoom call. Yes, the last but not the least, Ayush. Yes, obviously, I have mentioned this many times. I don't know when you joined the session, but I have mentioned this many times that I'm not sure about the recording of this. One participant, I guess Nitesh, he already mentioned if you want the recording, just start recording your screen from right now. Rajeshwari, I understand this is a bit confusing, and even I say the same thing to each and every student of mine that whenever we start with the PLC, it is kind of exhausting, it is kind of confusing thing. But once you understood each and every concept after around 4 hours, then it would be very, very simple for you. You will take interest in this. So don't be confused. Just try to understand that we have virtual hardware for now simulator, which is not official software from RS Logics, I mean Ellen Bedley. So in that place, we are using LogicPro. And whenever we use LogicPro software, obviously that is a simulator. That is not the original one. That is not the package of RS Logics or Ellen Bedley. So we need to like compromise with the few things. And that's what we are doing. We are compromising with the addresses only. So you don't have to be confused. When I say I colon 0.0/0, that means I'm talking about the hardware. And just in the place of this, if I say I colon 1/0, I'm talking about the simulator. So just focus on the last bit. In both, the last bit is 0. I colon 0.0/0, last one is 0, that is bit. And I colon 1/0, that is also 0. That means in both the cases, I'm talking about the very first input. And if I say I colon 1/5 or I colon 0.0/5, again, I'm talking about the last input of your PLC, one from hardware and other from virtual hardware called simulator. The serial key for AB is already available in the package of software I shared. Please check the SN text reading file, notepad file. I have mentioned this many times. If your RSLinks Classic is stuck at start, please go through the simulator. Right now, we are doing with the all the practice with that. Okay. Later after sessions, I'll have a live session on Zoom. We'll discuss the things there. Jivatma, I guess, because like too many students from engineering backgrounds are learning these things from me. So I'm teaching in a same way. I'm not considering because let me tell you one thing here. Too many students are there in this session. Also, we have too many working professionals are here, and it is not only for India. It is globally. So that's why I'm teaching in a style that I'm teaching to students only, right? Because always we cannot consider that they are this level, they are working professionals, so we need to take them accordingly. But right now, when we have mixed sessions, students as well as working professionals, so I'm taking according to students and considering that working professionals are also enjoying the same thing. We do not need any internet connection during the installation. Make sure if your internet connection is on, no problem, but we don't need any internet connection strictly. Okay? Okay, Jivat, I understood. You're from Nepal. Got it. Nearby to me. Okay, guys. I guess all the doubts are now solved. Let's get back to the main session, the technical session. I hope you guys are enjoying. Continue watching till the end. We'll meet again in the next doubt session, maybe uh, after the completion or maybe in between. Let's see. Okay. So good luck. See you again.
Doubts are clear, or maybe you don't have any doubts. So let's come back to this screen again. And one sec. Yeah, let's come back to this screen again. So this was the last program which we just created. Now let's go further. For now, I'm assuming few things, and according to that, we are going to create the programs. Okay. Let's say we have a motor. We have a motor and we want it to turn on. We want when we get the logic from sensor. For now, you can relate it with sensor as well. Input mean sensor. If you're pushing it, mean you're giving logic one. Same way, sensor will sense automatically give logic one. Both are the same things. Okay. So you have a sensor or a button. You want when a sensor is on or a button is on, motor should be on. When the sensor is off, motor should be off. So what you have to do? Simply, you have to take a NO, give the address I colon 1/2, give the address O colon 2/0. Make sure to connect the motor with this output and sensor with this input. We have already done this program. If you keep it on, motor on. If you keep off, motor is off. Right? But for now, as we know, it is a direct input. So you need to hold it to turn on the motor continuously. Right? Scenario one. Scenario two, if you want just opposite, like if you want when the sensor is on, motor is off. And when the sensor is on, motor is, I'll repeat, sorry. When the sensor is off, motor on, sensor off, motor on. Opposite. So you need NC. So give address again, I colon 1/2. Right? Now, after this, now why I am giving the same address at both places? Because I am changing this symbol. Right? Here I changed NO. So here I changed NC. If you want to keep address 1, suppose if you want to keep address 1, because we know that 1 is the NC address, right? So if you want to keep 1, then you need to take another program, but with NO symbol. So either change the symbol or change the address, because it has a concept. If you change both the things, it will reverse the logic. It has a concept which we cannot include right now, because that may take some time and confusing for you as well. So let's try to understand in a simple manner that either change address or symbol. So I am changing what for now? I am changing the symbol here, NC, right? So this one is also done. After this, let's come back to another scenario again. And the scenario is what now? That suppose we have a motor and we want it to on when the sensor is on. So let's keep it, and let's keep it sensor on, motor on, sensor off, motor off. We already did this program. But now what I want to include a new one here. We know that this motor is on till the time we hold this button, right? But in a practical scenario, obviously we are not going to hold the button. If it is a sensor, obviously we get the logic continuously. So if we get the logic continuously, motor would be on continuously. But if it's a button, then obviously you need to push it and hold it till the time you want the motor on. And other words, you can also say if your sensor is sensing only once, it is giving the logic one only once, and you want the motor to on continuously. So same scenario, that you cannot do that, because you need continuous signal from sensor, or you need continuous signal from this input to keep your motor on. I hope you're getting what I'm saying, right? As we know that this is a direct input category, so we need to hold it. If you replace the button with sensor, you need continuous signal from the sensor to keep your motor on. How we can solve this? Connect your sensor or the button at I colon 1/0, because we know it's a toggle one. Toggle one mean if it's a button, then push it, continuous current going, motor is continuous on. But if it's a sensor and giving you a continuous logic, it would be fine. But if it's a sensor not giving you continuous logic, sensing only once to keep motor continuously on, won't work here, right? So as a conclusion, I'll repeat what I said. Let's not make it too confusing. Let's start with the button only. Okay. If you keep I colon 1/2, it is a direct input. You need motor continuously on. Obviously, you need to hold it. If you don't want to hold it, use toggle button. This is simple scenario for buttons. But suppose, let me add one more scenario here. Suppose, as we said, if we have to turn on the motor continuously, and for that, as we mentioned, we will have to use toggle button. And suppose your spare parts does not has toggle button. There is no toggle button in your PLC. You have only direct inputs, and still you want the motor continuously on, and also you don't want to hold it. Obviously, if suppose we have to turn on the motor for around 10 hours, so obviously we are not going to hold the button, right? So how to make motor continuously on with the direct input only? 2 is your direct input. With this input only, I want the motor continuously on. So how we can do it? That is called start stop logic, which we are going to make now. Okay, so this is the second topic which we are going to start, and for that only I gave you this example. Okay, so with this button only, we want the motor to continuous on, and also we don't want to hold it, but we know that it will pass current till the time we hold. So how we can solve this problem? Using start stop logic. How it works? Let's see here. See, you push it, when you push, it will pass the current, motor is on. As soon as the motor is on, hold it. This is called feedback. Feedback is what? Feedback generally we take from output and work it as an input. In other language, this is a session of PLC which I am taking. Right now, as per your feedback, if you say it's going good, I don't need to change anything. But if your feedback is the session is not going good, so obviously, as per the feedback from your side, I need to modify the things. So that's what we are doing here. We are taking the feedback of the motor to hold the motor itself. Right now, I'll run this program here only. Okay, not with the software, here only. Suppose if you tap this button, it will become what? NC. I'll make it this way. It will become NC, right? If it is NC, it is passing the current. If it is passing the current, motor is on. If the motor is on, this NO is also NC now. Why? Because motor is high, so it will make your NO to close. Got it? I repeat. I understand it would be a difficult part, right? So let's understand again. So what I said, when you push this, it become closed, passing the current, keeping motor high. If motor is high, this is also closed. Now, current has two different paths to flow. If you hold it, current can flow from this path. If you don't want to hold it, current will flow from this path. Got it? So till the time, what we have done, we push this, it became NC, motor is on, and now we have this path for the current to flow. Whether you release it, whether you don't hold it, now the motor has continuously on with a different path, that is the feedback path. That is called start logic, only start logic. It is not stop logic for now, right? Now, how to turn off the motor? Now, let's say after 2 hours, 3 hours, 4 hours. See, when we talk about hours, we have a timers as well. But currently, I'm not talking about timers. We are finding out the sources till now, which we have covered. So, suppose if you have to keep your motor off after 15 hours, after 28 hours, after 5 days, 7 days, or randomly, because if you include the timer, there is a fixed time you need to mention that motor would be off after 2 hours or 3 hours, whatever you mention in your timers. But randomly, if you want to keep it off now, maybe after 10 hours, maybe after 15 hours, randomly you want to keep it off. So, how to do that? If you push this button again it will become close, and if become close, also it will pass the current, but it already getting the current, and we don't want the current again. We want to break the current, right? So the role of this button is over. Now it cannot do anything. It cannot help you to stop your motor. So we need to include another button with NC, right? Now we'll understand the whole logic again with a new button which we have included. Okay. So initially what we are doing, this is your start stop logic completely, and I'm giving it another address I:1/3. So we have two inputs, 2 and 3. So I'm using 2 to start and 3 to stop. Let's run the program again. Push it, closed. It passing current. It don't has any objection because it is already closed. Passing the current, motor is on. Motor is on mean this is also on. So now current has two different paths to flow. This path and this path. It will flow through this path till the time you hold it. If you release, it will flow through this path, right? So the final scenario after releasing the button is what? The final scenario is this one. You turned on the button, motor is on, hold it. And now current is flowing through this path. Correct? Now, when we have to stop, push it. If you push it, it become NO. I mean open. If you push it, it become open. Now, whatever current you were passing from here, it is not getting passed because the path is now open. If the path is open, the motor is off. If the motor is off, it is also open now. If it is also open, no path you have for the current to flow. That means motor is continuously off. That is called start stop logic, right? Now, let's without wasting our time, and try to run this in this software. Okay, so I'm going to make a simple start stop logic here. Okay, I keep one NO, hold and see. Right now, let's put it I colon 1/2 here, I colon 1/2, and here we are putting I colon 1/3, another input to stop, and then this one is your output, that is O colon 2/0, and here we hold work as a feedback O colon 2/0, right? When we started this, I clearly mentioned that we are not allowed to use the symbols of a coil in the input side. So can you see? I have not used the symbol. I'm just using the address. That means this output is behaving as an input here. If I do this way, this is wrong. This we cannot do. This one is wrong because it is now coil address, a coil symbol, I mean. So coil symbol is not allowed. It will give you error. Okay, I'll show you. I'll show you. Wait. For now, I'm not making it this. Let's make it this one. Okay, let's delete this one. Let's delete this one. Let's download the code. Now for download, I have told you this option, download to PLC. Okay, another option is click here, download and run. Now, if I push it and release, the motor is on continuously. If I push it and release, motor is off continuously. I'll do this practice two, 3 times continuously. Look at this, on, off, on, off, on, off. I hope this topic is clear to you. What is a start stop logic? So we have two inputs. So when you replace the toggle input, because this program can be made with only one toggle input as well, I colon 1/0 and then O colon 2/0, right? So we can make this program using one toggle input as well, but we assumed that we don't have toggles in spare, so we made the program with two direct input. So to replace one toggle, we need at least two direct inputs. Okay, but further, when we learn too many other things as well, that time we can make it with one input as well. Okay, let's go further. Now, let me make it again. I'm sorry, I deleted it. Panel is not working. Let me reopen the software. Okay, if you don't want to write the address, then you can also drag from here to, and 2/0 is your output. Another NC we need for the close. So let's drag it from here. Okay, now one output we need here. Let's download. We have already seen this, but I want to include something else here, right? So I'll start with that. Start, stop. Right. Now, if I want to start the motor, but turn it off automatically after a few time. So time mean, obviously we need to start with the next topic, that is timers, right? So we have a different variety of timers available with us in this Ellen Bedley, on time delay and off time delay. And third one is retentive timer. So currently we are talking about the on-time delay, which has T on as a symbol. Okay, T on. T on mean on-time delay timer, a timer which will start just after turning it on, right? So let's come to timer directly, right? So I need to go to PGM mode. I need to go to here, and then let's connect timer from here. So timer, T on. Okay. Timer need an input to turn it on. So I'm connecting a NO here, right? I'm not taking another buttons. I'll use this logic only to turn on the motor, turn on the timer. So whatever was the output of your start stop logic, let's keep the same as the input of your timer. I repeat what I said. I'll not go for another input to turn on the timer. So what I did, I am using the same input which we have used as an output in the start stop logic. But practically, if I tell you, practically, we want this motor to turn off after some time. But the program which we have just created is giving us a message that timer is dependent on the motor. Instead of that, the motor should be dependent of timer, right? So currently we are not doing it in a correct way. Let's first try to understand how it goes wrong. If we understood that, we'll do it in correct way as well, right? So what are the address? Because timer is also asking for the address. So let's write the address for the timer T4 colon 0 to T4 colon 39. I told you when we started for the data files that we have too many data files available, right? Input output we already understood. Now we are trying to understand about the timers. So we have 40 timers available when we work with ML1000 series, which we are doing right now. If we change the series, then we have T4 colon 02, T4 colon 63, total 64 timers with micro logics 1100 and 1200. And then T4 colon 02, T4 colon 127 ml 1400 and 1500. I have this one also with me, which I show you in the between the session, right? The that side, which is right, and this one we are doing for now. So for now we have only 40 timers starting from T4 colon 0 to T4 colon 39. These are the addresses. So now let's come back to this one and let's write T4 colon 0. Now, preset. Preset is how much time of delay you need. How much time of delay you need. Okay. You need to mention the delay in seconds. The unit is in second. And the maximum value is 16-bit value. The timers you have for 16 bits. 16-bit, if you calculate, is 2 to the power 16, which have a range of plus 3276. Let's start with minus 32768 the range of plus 32767. Simply you don't get confused. What we have to do, the timer is for 16-bit. Okay, so simply calculate 2 to the power 16. It would be what? It would be double of this value, which I have mentioned in signed form. Okay, if you calculate 2 to the power 16, you'll get something around 64,000 something, yeah, 65,000 something. So I have divided that into the signed values, minus and plus, right? So maximum delay you can take is 32,767 seconds. Okay, and here you need to mention, suppose 1 second of delay. So if you write 1, it is not actually 1 for now, it is 0.1, because base time is also important. The role of base time we need to understand here. Okay, let's have a simple formula. Timer timing is equals to base time into preset. So if you want a timer to run for 1 second and you have a base time of timer is 0.1 fixed, you can see it here. You have a base time as a 0.1 fixed. So that case, you need what? You need to multiply it with 10. If you multiply it with 10, it will give you 1 second of delay. But 1 second is very less for now to understand the things. So I'll make it 10 seconds. So for 10 seconds, we need to keep the preset as 100 because 100 multiplied by 0.1 is equals to 10 seconds. So that's how it will give you the delay of 10 seconds. So let's write, come to this window. Let's write 100 here. So 100 into 0.1 is 10 seconds. So we have set a timer of 10 seconds and we want the motor to turn on for 10 seconds and off automatically after 10 seconds. So let's run the program. If I keep input on, timer is running here, right? Timer would be off after 10 seconds, but motor is not going to off because currently the motor is not dependent of the timer. Timer is dependent of the motor, right? Second thing, suppose if we keep it here, if we keep timer here, that is also not possible. Let me do that also. That is also not possible because now we need to remove it because we cannot use as a feedback of timer. So now start stop logic is not going to work. So completely we lost with the program. Now how we can make your motor dependent of your time, right? So for that, we need to understand another file, another data file, which is called binary files. Binary files is B3 colon 0 slash 02, B3 colon 0 slash 15. So in total, we have 16 binary files starting from B3 colon 0 dot slash 02 0 slash 15. And the best part, we can use this binary files as input or output as well. Input or output as well, right? That means you can use with NO, with NC, and with coil as well. And these are in software. Because in the hardware, we have only two things, input and output. Timer was also not there. Timer is inbuilt already in PLC. And the same way, binary is the part of software. So you can use it. It's not going to turn on the hardware because it don't have hardware already, right? What I mean to say, to turn on the timer, now we are not going to use the motor. We will be using one binary file, right? We have only four outputs. Currently, we are working for one motor. Three are still remaining. So we can use another output as well to hold and to turn on the timer and then to turn on the motor. But still, we don't want to waste the outputs. What I mean to say, let me do it. Suppose if we say we have to make a motor dependent of timer. So let's take another output here. That is O colon 2 slash 1. So let's keep it O colon 2 slash 1. Let's keep it O colon 2 slash 1. So this may be a scenario we can do this. Like we have a start button. Let's turn on this output and this output will turn on the timer, right? And then timer will turn on the motor for 10 seconds. Once the timer is off, the motor is off. We can do this, right? But can you see we are wasting this output? We have very limited outputs, only four, out of which one we are wasting to simply turn on the timer. So we don't have to do this. That's why I told you about binary files. There may be another point. Why we doing all these things? Why we don't simply take an input and a timer? Because let me show you this also. If we do this, timer will run till the time you hold the input. Timer also need continuous current to on. Let me show you. If I tap it once, timer is going, but if I release it, timer is off. Look at this. This one, yeah. Here I'm tapping on. Timer is continuously working, but if I release it, the timer is off. So timer is not working if we don't hold this button. So to hold it, either we need toggle, and if we don't have toggle in spare, we need to use start stop logic. Right now, I guess everything is clear. Each and every concept I have included here. If you have doubts, you can ask me, no problem. So I'm making it another output O colon 2 slash 1 and then another output O colon 2 slash 1, another output O colon 2 slash 1, then a motor O colon 2 slash 0. But we have to reject this scenario also because in this case, we are wasting one output to control the motor. So let's make it binary file B3 colon 0 slash 0. It can work as output as well as input. Binary file, same. We will tap this button, start button, it will keep binary high, hold binary, continuous timer on. When we have to stop, stop it, binary off, binary off, binary off, timer off, right? This is the scenario if we control it manually. Second scenario, turn on the button, binary is on, binary hold it, passing the current to timer. After 10 seconds, the motor should stop, right? Let's now run this. So this way we can see the motor is on and after 10 seconds it should be stopped. But no, 10 seconds are completed. It's not stopped. Now we need to include another concept. Another, and trust me, the last concept and after this, it is very easy. The PLC programming is going to be very easy after this concept, right? After this, everything is easy. Let's try to have it here. Okay, so why the motor is not off? Because still the timer is passing the current. So if you connect the motor just after the timer, it won't work because timer has continuous current from the input side. So it is passing the continuous current to motor. It does not impact because of the delay which you have taken here. If you have to establish the role of delay, you need to include one last concept of the timer, that is called bit of timers. Bit mean 01, 01 mean NONC. So what I mean to say, we can use the bits of timer wherever we have to work as a NONC. Let me clarify you more. Timer has three different bits, EN, TT, and DN. EN is called enable bit, TT is called timer, timing bit, and DN is called done bit, right? I know that this is 2 day session and we have to include too many concepts, so it might get confusing at this time. But trust me, if you go for a long period, if you go for a long course, then that time it won't be in this way right now we are doing, because right now we have to focus, we have to touch each and every concept. That's why I'm doing it in this way. But when we have a long time period to learn, we'll be learning it by practicing, by solving each and every problem, and also we will be like very slow in that manner to like get everything clearly, so that we don't get confused with these concepts. Right now, I understand it would be difficult after the first session. You need to recall each and everything. That would be appreciated to understand the second session. I'm so sorry because we have a limited spare of time, but as I said, if we get the good feedback of this session, then we'll plan for a long-term period as well. Okay. Now come back to this. Just motivating you because I know it's getting quite difficult. So we have three bits of timers: enable, TT, and done, right? EN is called enable, TT is called timer timing, and DN is called done. How these works? Let me show you with the graph. Okay. So we have what? We have a input button to start the logic. This we used to start. So whenever you start, timer enable bit goes high. Bit mean 01. It can be used as NO or NC. NO or NC. And obvious, if we use anything with NO or NC, they need address also. So I'll tell you the address of each bit, how to write the address. But first, let's clarify. When we turn on the input, enable bit goes high. TT bit also goes high. Enable bit shows that timer is getting the current. TT bit shows that timer is changing the time. Timer is providing the delay. Okay. But done bit doesn't go high because done bit shows whether the work is done or not. Okay. So if you have a timer of delay 10 seconds, obviously done bit is going to high after 10 seconds. Done bit is going to high after 10 seconds, right? Enable bit is permanently high till the time timer is getting current. TT bit is also high, but after 10 seconds, it will get low. 10 seconds for now. Okay. It is not standard. 10 seconds for now because we have set 10 seconds of time delay in my timer. So TT bit shows that timer, as soon as you start, TT bit goes high till the time is covered. If the 10 seconds are done, TT bit goes low. Automatically, it goes low. And at the same time, then bit goes high. Clear? I'll repeat. When you start, enable bit goes high because it is getting current. TT bit goes high, but only for 10 seconds because timer will change the time only for 10 seconds, as you have set only 10 seconds in your timer delay, right? And then bit goes high after 10 seconds, which shows the work is done, the task is completed. And if you stop it manually, if you stop the input I:1/3 manually, everything goes low. TT was already low, enable low because of current, and done is also low because whenever you stop the timer, it goes to zero value, right? So if you see in the timer, we have what? We have accumulator, preset where you set the value of timer, how much time you want for a delay. But accumulator is what? Accumulator shows you time, how much delay timer has provided, how much time delay has timer has provided. It will show you each and every value starting from 1 to 100, right? Come back to this again. So if you use enable bit, it has an address T4 colon X slash EN. If you use TT, it has an address T4 colon X slash TT. And if you use DN, it has an address T4 colon X slash DN. And X is what? X is nothing but the address of your timer. You have timer starting from 0 to 39, as I mentioned. So each timer has enabled TT and different DN bit, right? So if you use T4 colon 0, you need to write T4 colon 0 slash EN. If you use T4 colon 10, it would be T4 colon 10 slash EN. Now it is easy to understand. Let's now verify this graph, which we already understood here. So what I am doing, I'll not solve this problem for now, for motor problem. We'll solve it later once we understood this topic. Okay, let's delete the motor. Let's take three inputs, one input output, copy the run and paste below or paste below. Okay, and then now let's write the addresses of enable T4 colon 0 slash enable. Why I'm using 0? Because we have used T4 colon 0. Then this one would be TT and last one is DN. And now let's take three different outputs to verify how these bits work. O colon 2 slash 0, O colon 2 slash 1, and the last one is O colon 2 slash 2. Right? Now we have to check which bit is on, which bit is off, how they work. Each and everything we'll understand through graph. So I'm starting this. Before we start this, let's come to graph again. Enable bit goes high as we start. TT bit goes high as we start. TT bit low after 10 seconds. Done bit high after 10 seconds. And when we stop, all off. Right? So it's very simple. When work is done, done is on. Initially, TT is on. When the work is done, TT is low. And enable is manual bit, like when you start on, when you stop off. So we not need to focus too much on the enable bit. The two important bits are TT and DN. DN is simple, work done equals to high. TT is initially high, work done equals to low. Right? Now come back. So I'll start. As I start, we can see enable and TT are high. Timer is providing the delay. Accumulator is showing you each and every value. After 10 seconds, as per the graph, TT should low, done should high. Look at this. After 10 seconds, TT is low and done is high. And we stop, if we stop manually, all goes low. Again, I'm running it. I'll not say anything now. Try to understand. Okay. So TT was initially high when we started, low after 10 seconds, done high after 10 seconds. TT low after 10 seconds, done high after 10 seconds. Got it. So now we got the concept, the final concepts. Let's now make too many programs fastly. Okay. Now let's include that problem of motor. So we have a motor and we want to turn off the motor automatically after 10 seconds. So which bit should we use? Comment it fast. I'm waiting for your comments. Which bit should we use if we want this motor to turn off automatically after 10 seconds of start? Okay, so I'm putting it, getting too many comments. I guess I'm recording this session, just guessing it. Okay, T4 colon 0 slash TT, because we know when we start, TT goes high. When we start, TT goes high, and after 10 seconds, TT goes low. So after 10 seconds, it will turn off the motor. Let's run, download and run. So now let's start the circuit again. As we start, motor is on because of TT, and after 10 seconds, motor will go low automatically because of TT bit. We solved it now. Okay, the concept which we started around 20 minutes back, we have solved now. Now we can solve too many problems. Now let's say if we have to turn on the motor, we after turn, I mean like when we turn on, the motor should not be on. After 10 seconds, we have to turn on the motor. So we have to use done bit. So now you can also sync your sensor. If you're getting only one logic from the sensor is on, and then after 10 seconds, motor is on. If button is on, after 10 seconds, motor is on. Sensor button, same. Okay. Motor on. And if you keep off manually, it's off. Right. Now, let's say if you have two motors and you want one, first motor on, and after first motor, second motor should be on after 5 seconds or 10 seconds. Let's say 5 seconds now. So let's change it to 5 seconds. Now I'll do what? I'll keep two motors T4:0/TT, another motor T4:0/DN. So first motor is on, and after first motor, second motor would be on. Delay 5 seconds. Not 0 only, it should be 1 now. Right? So let's download and run. So first motor is on, after 5 seconds, second is on. Great. Now, if we have three motors, so let it say we have third motor as O:2/2, and we want it to turn on after 5 seconds of the second one. We need to connect one bit, but unfortunately, after done bit, there is no other bit, right? So now one other thing which we need to include, let's have another timer here. How to connect one more timer? You not need to set up each and everything again. Simply take parallel connection. Okay. And then in this parallel connection, take one NO, one timer, right? Now make it T4:0/DN. Why I am doing this DN? If we don't put it, both timers will get the current at the same time and both will start at the same time, right? So you need to make it 50 and 100 in this way. If you keep both in parallel and you don't want to keep any control here, both will start at the same time, but it will give delay of 5 seconds. It will give delay of 10 seconds. Why do we need this? Because as we mentioned here, first motor will start with the enable bit. Second motor will start with this done bit. That means after 5 seconds. And this motor we need to start after 5 seconds of this, which means total 10 seconds after first motor. So we'll keep the second timers done bit here. But this is quite confusing if we have too many outputs. When we have only three outputs, it is good. But when we have around 10, 15, 20 outputs and keep all the timers in parallel and keep adding the delays of previous timers as well. For example, if we need to connect 40 timers together, so the delay of 40th timer would be the addition of 39 timers delay plus its own delay. So it is quite difficult. So let's keep it independent. How? Make it, keep it done bit of first, and then keep it individual delay, independent delay of 5 seconds. So now when you start, obviously we know binary goes high. Binary will pass the current to both the timers, but this won't get that current till the time this the done bit is high. And done bit would be high once this timer is completed. So this way, first it will complete, then it will start. Getting my point? So I'm not making any program for now. I'm not checking any output, simply checking how timer works in parallel. See, I started. First timer is running, second one is not because done bit is not high till now. Now the done bit is high after 5 seconds. So now second timer is running. So now it is easy. Now how we can do? Let's keep it 1. Second timer's done bit. So now we have solved the problem of output as well. The first motor is on. After this, the second goes on. After that, the third goes on. But there is a problem again here that first motor was off when second on, but second didn't off when third off on. Second didn't off when third on. So we can solve this problem too. We have too many ways. First, let's pick a very simple way. Let's pick another timer, third timer. Okay. We know when we work with the done bit don't goes automatically low. because we need to keep it manually off. You can see here when we keep I:1/3 off, when we keep I:1/3 off, then only the done bit is low, right? So I'm making a very simple concept for today's session, that is another timer, and this timer should be on after the second timer. So let's include another timer T4:2. And T4:2 is now dependent of T4:1, and T4:1 is dependent of T4:0. So when you start, binary goes on, binary turn on this timer, after 5 seconds this timer, and after 5 seconds this timer. So now let's not include the done bit anywhere. Let's keep it TT everywhere. Here also, I'm keeping it TT of 2 so that each motor can start after 5 seconds, and when the next motor is on, last should be off. This was important. For that only we are doing this, because TT goes low automatically once the delay is over. So now let's run it. First timer is running, first motor is running, first motor off, second motor on, second timer running for now. And when second timer off, second motor off, third timer running, third motor on, third timer completed, third motor off. I briefed. Now I'll run it again so that you can check how it is working. Okay, so I guess it's enough for today's session. We'll close it with one program of the hardware. We will make this same program in the hardware, and then we'll close it for now. And rest we'll include tomorrow. For now, we may have a live session if you want any doubts, any clarification and all. Okay, I'm here listening you live. Start commenting whatever questions you have, and then I'll solve your doubts. If still you have any doubts and I'm not able to solve it here, then obviously, or maybe like you can't write each and everything in the comment, then we can go with the flow, I mean, with the live sessions at the Zoom or other platform as we discussed earlier, right? So let's create this program fastly in the hardware. So I'm closing it. Let's come to hardware, making the same scenario, and that is what? One start stop logic, one timer, parallel, and another timer, another parallel, and another timer, right? I'll zoom it once I assign the address, okay? And then at last, we have to include the combination of input output, copy and paste and paste. All right. Now let's zoom it to assign the address. So as we know, now we're working with the actual hardware. So we need to put actual address, that is I:0.0/2 and I:0.0/3. Let's not make it confusing because I have already told you the actual addresses. So you can follow these address now, right? And it is binary address is same. Only input and output address are going to be differ in the case of simulator and hardware, right? Rest all addresses are same. Then it is T4:0 itself. But this time when we have to run it for 10 seconds, we have to write 10 only because now we have the time base of 1. In simulator, we were having the time base of 0.1. As I mentioned here, where it is, here it is, time base of 0.1. So we need to multiply by 100. But now when we're working with the actual, we have 3 base time options. I'm using 1. Okay. And 10 seconds. Now T4:1. If you have curiosity why we have these base times, different base times, what we can do, comment it. I'll tell you. 10 and T4:0/dn, T4:1/dn, T4:2. We'll keep the next session a little long, okay? Because it was a first session and I don't want to put too much pressure. So I kept it small, but tomorrow we'll keep it long so that we can cover too many things. As I planned, we have to include advanced version of this PLC and then Siemens as well. Okay. So we'll keep it long tomorrow. And in future, I'll be planning for long sessions, and also I'll try to have SCADA. So T4:1/TT and T4:2/TT. Now, if I do this, that is O:0.0/0, the first output. Let's copy everywhere and a bit change. It's 1 and it's 2. Okay, I'm done. I'll let you know what I've did. What I've done, start stop logic, and then with the binary, one timer, done bit second timer, done bit third timer. This is the done bit of this timer. This one is the done bit of this timer. Now with the TT, it's output first. With the TT, output second. With the TT, output third. Now let's download the code. We not need to communicate again because PLC was already communicated and we didn't turned off till then. So we not need to communicate it. If you turn off the power, you need to communicate again. If you turn off the power, or suppose if you uh, remove the cable in that case. Okay, so I'll start the code in the hardware directly so that you can see. Okay, so we have three outputs. Start button, we need to wait for 30 seconds for this whole cycle. 10 seconds, 10 seconds, and 10 seconds. So currently the first one is on. After 10 seconds, the second one is on. Let's wait for another 10 seconds for this one. Third one, last one, and after 10 seconds, it is also going to turn off. So now, as we have already understood the basics on the timer, tomorrow we'll start with something else. And also, I'll try, like in the next session, I'll not keep this PLC, I'll keep another PLC. Same addressing methods, nothing changes. It's just number of inputs increases, number of outputs increases. Okay. Rest, no changes. So I'll try to include that one also. So that's it for the day. Thank you so much for being here. Thank you so much for your support and patience, as I mentioned in the starting of the session also. And I'll keep you updated through WhatsApp channel and the Telegram, right? Thank you. Bye-bye. Take care.
Okay, guys, so if you have any questions or doubts, please start commenting. I'm again live with the comment part. If you have any questions or doubts, please comment fast. Okay, so I got a response of please repeat what the purpose of bit timer is. Can you please mention which bit are you talking about? Because I have mentioned three bits during the live session. It was enable, TT, and DN. So enable starts as soon as you start the timer. TT also start at the same time, but done bit start according to the delay completion. TT bits ends once the delay is over, and done bit ends. Done bit start when you actually see the timer has completed the delay, and once you stop the circuit manually, each and everything stopped. So if you have any other query, please write it. Okay, that's good to see you here, everyone. I guess no one has any questions. Now, as promised, let's meet in the Zoom meet. So, how many participants would be there? Can you please write in the comment box? How many of you are interested for the Zoom live Zoom session right now? That won't take much time, okay, because that is according to the doubts. We'll take that session for around 20 to 30 minutes, depending upon the doubts actually. I mentioned this thing in the Telegram and WhatsApp as well, that doubt session depends upon the number of doubts. Yes, you can use the software with the internet, no problem. Please write how many of you are interested for the Zoom. Write simply write Zoom. I'll understand this. For those who have doubts, any questions, any problems, any queries, I'll be solving all of them. I have not created any Zoom meeting till now, so I'll be sharing that link soon. Once you share that you are ready for that, I'll share that link to Telegram and WhatsApp. Would take around 2 to 3 minutes, not more than that. Serial key was already mentioned by someone in the comments if you have seen, and if you have not seen, just join the Zoom session. I will show you. Yes, I have already sent the Siemens softwares to install. Just check the Telegram and WhatsApp channel wherever you are. So there we have two links, one for AB, Ellen Bedley, another for Siemens. Later, I provided the alternate links for AB. Anoki, right? See, it's not possible to write here because I have joined through many devices and I need to also check. So better if you join the Zoom. I'll be showing you at the same time. We are not going to have HMI or SCADA tomorrow at Razi because, as discussed, we'll be doing only PLC. These 2 days are engaged for PLC only, not for SCADA or Zoom. I mentioned during the main session that in future I'll be planning for the Zoom session if you want that. Okay, I guess now it's done. No doubts for now through YouTube live streaming. Let's meet into the Zoom call because I got many responses by comments. So let's meet there within next 1 to 2 minutes. I'll be live there. I'll be sharing the link through Telegram and WhatsApp. So set up your Zoom as soon as you can do, and